Swing is a widget toolkit for Java desktop applications. So what's a widget? Everything you see here in this graphical user interface is a widget. The buttons are widgets, the drop-down combo boxes are widgets, the text fields are widgets, the labels to the left of the text fields are widgets, and the checkboxes are widgets. Swing provides these widgets that you can use to create your own graphical user interfaces. Swing is cross-platform. You can write your Java application on any operating system that supports Java. Then you can run that application on the same operating system or on any other operating system that supports Java. Java's slogan is write once, run anywhere, and Swing is not an exception to that. Swing has been part of Java Standard Edition since version 1.2 in 1998, and it's received incremental updates on all Java SE releases since then. Because it's part of the JDK, there's no separate jar file you have to download, register with your IDE, and deploy with your applications. Java on your computer already contains Swing, and Java on your user's computers already contains Swing, so there's no deployment issue. Swing is for desktop applications, sometimes called rich applications, but it's not for Java EE applications. It's possible to write web applications or thin clients in Java that use widgets, but that's not what Swing does. There are separate libraries for that. However, if you really want to launch some Swing code from your web browser, there are two ways in which it can be done. Neither of them is especially popular these days, but it does work. The first is to write a Java applet with Swing components and to embed that applet in your web page. The second is to deploy an application using Java Web Start. Java Web Start can put a button on your web page, and when the user clicks on that button, it will download your desktop application and run it. Swing is not the only widget toolkit for Java desktop applications, so let me mention a few others. First is the AWT, which has been part of Java since the very beginning. Its approach was to provide an API for using the operating system's native widgets. Achieving consistent cross-platform behavior is one issue with this approach. Swing was built on top of AWT. It wouldn't quite be correct to say that it replaced AWT, because some AWT APIs, such as those for layout or for event handling, are used verbatim in Swing. But Swing does provide replacements for AWT's components. So a Swing application would use Swing's button class and would ignore AWT's button class. Swing's approach is to create Java implementations of the widgets and not to use the operating system's native widgets. Swing was rolled into Java 2 in 1998. SWT was originally created by IBM and is now an open source project maintained by the Eclipse people. It sort of takes the same approach as AWT did, to use the operating system's native widgets, but it builds on it. If getting your hands on the operating system's true native widget sounds appealing to you, you should take a look at SWT. I don't know a whole lot about Qt or Apache Pivot, except for they're both open source and they're both viable widget libraries for creating desktop Java applications. JavaFX version 2 was released by Sun Oracle in 2011. It's an alternate widget toolkit for desktop applications that was intended to be more modern, more capable than Swing. JavaFX version 2.2 was rolled into Update 6 of Java 7 in 2012. That was followed by JavaFX 8, skipping over versions 3, 4, 5, 6, and 7, which was included with Java 8. So the JDK actually includes 3 different widget toolkits: AWT, Swing, and JavaFX. Some might say that Swing is old and shouldn't be used anymore, but others say that Swing is stable and mature and is often a better choice. Course prerequisites. You should be familiar with programming in Java. You need not be an expert, but you should know the basics, like how to create classes, including the occasional nested class, how to create member fields, how to create methods, including the main method, how methods are called, simple flow control using if and for, and basic collections classes such as ArrayList. Pretty much all the course examples use lambda expressions, which were introduced in Java 8. But the course examples in general can be rewritten to use nested classes instead of lambdas, and they would run fine. In addition to lambda expressions, a few examples use generic types or the enhanced for loop, both introduced in Java 5, or the diamond operator introduced in Java 7. So the simplest thing to do is just to use JDK 8 or newer. But without too much trouble, the course examples can be modified to remove these specific language features and work with older JDKs, even JDKs as ancient as Java 2. There are a few exceptions to that. For example, when we talk about tables, I demonstrate some row sorting functionality that wasn't added until Java 7. So obviously that particular code won't work under JDK 6 or earlier. Another example, when I show how to set a JSpinner from the value of a java.time.localDateTime object. That won't work under JDK 7 or earlier because the java.time package wasn't added until Java 8. While you can certainly watch me run the course examples in these videos, you will probably want to compile them and run them yourself so you can experiment with them. I happen to be using Eclipse 4.4 in these videos, but nothing in this course is IDE specific. So you can use any IDE, including NetBeans, IntelliJ, and earlier or later versions of Eclipse, or you can even use a simple text editor and do your compiling from the command line. However, I've placed the course examples in the com.bitguru.aura.sc.swing package, which is potentially cumbersome if you plan to use a text editor and the command line compiler, because you'll need to place them inside a bunch of nested folders. Feel free to change the declaration to the package of your choice, or even the default unnamed package by removing the package declaration entirely. Finally, you should know how you want your graphical user interfaces to behave. You'll have to replace the printline calls in the event handling code with code that actually does something. In this lesson, we're going to create a very simple Swing program that displays a message. All Swing classes should be in some package. It doesn't really matter which one you use. I'm going to use this one. Most of the Swing classes are located in two packages, so let's import them here. The first one is javax.swing. Second one is java.awt. Now, if you're using an IDE, you probably don't have to do that. You can just rely on the IDE to automatically add the imports for you. Let's define our main method. Let me make a note to myself that we're going to do something in main that technically shouldn't be done in main. We'll address that in the next lesson. Swing components begin with the letter J. So there's JButton, JSlider, JTextField. We'll create a JLabel to hold our message. This will be the content of the message. That's the easy part. The harder part is making it visible to the user by putting it in a frame. Create a JFrame. This is the text for the header of the frame. Let's add the label to the frame, or to be more precise, let's add the label to the content pane of the frame. If we don't provide any constraints, it'll go in the center. Let's give the frame a size. Let's say 240 pixels wide, 160 pixels high, and finally, let's set the frame to be visible. Now, if I run this program, it will appear, but there's an issue, and that's if I close this window by clicking here, the program is still running, and I have to manually kill it for it to actually terminate. This is usually not what you want, and so a way to fix that is to call frame, set default close operation, and set it to exit on close. Now when we run this, when we close the window, the entire application closes. Okay, we can fancy this up a little bit. One thing we can do is provide an alignment for the label. This will center it. And if we'd like, we can specify a bigger font. Give it a font name. Font style could be bold or italic instead of plain. And a size. Now it's bigger. We can set a color by calling set foreground. These methods, set font and set foreground, aren't specific to JLabel. They work for almost all J components. In this lesson, we're going to discuss the event dispatch thread. The event dispatch thread is the thread that Swing uses to handle user input, such as mouse movement or key presses, and also uses to paint components in windows that it manages. However, the main method is not called by the event dispatch thread. It's called by the main thread, and this is a problem because it violates the Swing single-threaded rule. The Swing single-threading rule is this. To avoid the possibility of deadlock, you must take extreme care that Swing components and models are created, modified, and queried only from the event dispatching thread. Now, there's a couple exceptions. There are a few Swing methods where if you check the Java doc, it says that they're thread safe, and so you can use those from any thread. Also, adding or removing event listeners, such as action listeners, mouse motion listeners, can be done from any thread. So the way we fix this is that we move all this code into a different method. It doesn't really matter what you call the method, but I'm going to call it startup, and I'm going to make it a non-static method. For most applications, it works better. And now, in the main method, we need to invoke the startup method in the event dispatch thread. And the way we do that is by calling a method called invokeLater that's in the Swing Utilities class. Now, the argument to invoke later is a runnable object. The simplest way to do it is to use a Java 8 Lambda expression that maps 0 arguments to creating a new instance of Hello World and calling it startup method. So now the program works and we haven't violated the swing single-threaded rule. If you're running a version of Java that's older than Java 8, then this syntax isn't allowed and you have to provide a runnable object, perhaps an anonymous one. It would look something like this. New runnable. And you define the method run. And then inside run, you instantiate the new hello world and call startup. And now this will behave just like the Lambda expression does. But it's easier to do this. This lesson is on look and feel. Swing supports multiple look and feels. Look and feel can be abbreviated LAF or LNF. I'll usually call them LNFs. To show you what I'm talking about, I've created this program already. It contains a tab pane, a combo box, a button, scroll pane containing a text area, and a slider. But the point isn't the code. The point is what these components look like in different look and feels. So I've run this program 4 times, each with a different look and feel. Let me pull those up so you can see them. So from left to right is the metal LNF, the Nimbus LNF, the CDE LNF, and the Mac LNF. You'll notice that the components look and behave differently, but I also want to point out that the sizes of some of the components are different too. So for instance, the width of this combo box is greater than the width of this combo box. What this means is when we do layout and swing, we can't know at compile time what size the component will be because it depends on the LNF. And even if you hard code a particular LNF in your program, the LNF could be updated in future versions of Java. So it's something we have to be careful of. This is a list of the 6 LNFs that come with swing. The first 3, Metal, Nimbus, and CDE, can run cross-platform. The next 3, in red, Windows, Mac, and GTK, have restrictions on which platforms they can run on. So Windows LNF can only be run on Windows machines. Mac LNF can only be run on Mac machines. And the GTK LNF can only be run on Unix machines in which GTK library has already been installed. There are also LNFs that don't come with Java. There's some open source ones, you can search source storage for them, or there's some commercial ones which you can license, or you can even write your own, but writing your own can take a lot of effort. If you'd like to know which LNFs are available, you can call this function UI Manager Get Installed Look and Feels. This returns an array of look and feel info objects. Comment this line out. So if we run this program, we'll get a list of the LNFs supported on my machine. Metal, Nimbus, Motif, CDE, and Mac. Notice Windows and GTK aren't on here. Now, if you'd like to set a particular LNF, you call this function UI Manager Set Look and Feel. This method does throw exceptions, and so you either have to catch them or do something like this. So let's try this. I'll uncomment setting the Nimbus Look and Feel and run, and that's Nimbus. Or I can do the same thing for Metal and run it. And this is Metal. If you're going to do this, it should be one of the first things that happens before any swing components get instantiated, or even before the class loader loads any swing classes. So it should definitely happen before this call to startup that launches our GUI. There's another way to do this, which is instead of doing it in the code, to use system properties. Let me go set up the command line arguments for this run for Metal and run. And there it is in Metal. This is what I'm going to do, in fact, for most of the examples in this course. I want to use Metal so that my layouts look the same as layouts that you might use no matter what machine you happen to be using it on. This lesson is about using images with JLabel. You know that JLabels can handle text like this, but they can handle images just as easily. Swing provides an interface called icon, and the simplest class implements icon is called image icon. All we have to do is give a path to a file on our disk, like this. It accepts GIF format, JPEG format, PNG format, maybe a couple other formats, but those are the major three that most people use. I want to point out that it's appropriate to use a / even on the Windows file system where / is technically the separator. I'm not on a Windows machine. I have an image here. And all I have to do is replace this string with the icon. It's that simple. I do want to point out something important, which is if it can't find the image you give, it doesn't throw an exception, it just doesn't show your image. So that's something you have to watch out for. The image icon class also handles URLs, but you can't do this. It's tempting, because if you do it this way, it will interpret the string as a file name on your disk. So what you have to do is say new URL, and now it will accept this as a URL and fetch the image at the location you specify. I've already imported the URL class, which is up here, JavaNet URL. But URL's constructor throws exceptions, and that's why I'm seeing this error message here. And I could put a try-catch around this, but I've already written a method down here called getGreenSmiley's URL that essentially returns this URL. So let me just call that. So there's a couple things to notice here. One, it really did pull this image data off of a web server. Also, it can handle animated GIFs. And third, it can handle transparency because this is a transparent GIF. And even if we were to change the background color of this frame, you would see that color through the transparent pieces of this animated GIF. There are two other ways to get URLs I'd like to show you. One way is to call getClass, getResource. What this will do is search the class path at the location where the class file for this class, ImageLabel.class, is stored. This image I have stored in the same directory as the source file for ImageLabel. And finally, there's a static method in ClassLoader called getSystemResource. This is similar to getClassGetResource, except it will look at the root of the class path instead of at the location of this class. So in fact, I could make this work by manually inserting the elements of our package name. So 4 ways to get our image files into an image icon. Specify a file name, specify a URL, or use one of these 2 methods to get an image file off of the class path. That's image icon. But if we wish, we could just implement the icon interface ourselves manually. Let's do that. Now, there are only 3 methods you need to implement for the icon interface. GetIconHeight, GetIconWidth, and PaintIcon. So let's make a variable for the size, and we'll return that size for the height and the width. What we have to do here is use the graphics object to paint the icon from point XY to point X plus width, Y plus height. It doesn't do any clipping or anything. It would be possible to draw things outside the bounds that we've set for ourselves, but that would be an impolite thing to do. And I think it's polite to set the color back to black. It can be this simple. Let's go back to our ImageLabel class. We're going to have to write the constructor. Now it should work. So if we want, we can make this ball icon a little fancier. This object G in the icon interface is typed graphics, but in fact it is almost always an instance of a class called Graphics2D. And the Graphics2D class has some methods to do fancier things than what the graphics class allows. For instance, Graphics2D has a method called setRenderingHint, and we can use it to tell it that it should try to use anti-aliasing. If we do this, the edges of our ball may look a little nicer. But we could also use Graphics2D to paint with a gradient. Let's do that. So we need 2 colors. And we need a second color for the other side of the gradient. And we'll define a radial gradient paint. Give it the radius of the gradient, which I'm going to make 50% larger than the actual radius of the ball. And then we have to give it some fractions, which I'll define in a second. and the array of colors. Then all we have to do is cast G to a graphics 2D and call setPaint and give it our gradient. Now we don't want to do this anymore unless G is not an actual instance of graphics 2D. So let's run this and see how it looks. Gradient shading. There's one last thing I want to show you before we end the lesson, and that is that with a JLabel, you don't have to choose between an icon and text. You can have both. You just specify the text first, then the icon. By default, the text will appear vertically centered and to the right of the icon. But the position on the vertical axis and the position on the horizontal axis can be specified manually. For instance, call greeting set horizontal text position. We could say center here. And then we can set vertical text position. And let's say bottom. And now if we run, text will appear below the icon and centered horizontally. If I change this to the left, the text is to the left of the icon and it's aligned with the bottom of the icon. One last thing, if I set both of these to center, then the text will appear right on top of the icon. We probably want to set a smaller font. That's the end of our lesson on using images with JLabel. This lesson is about the size and location of the JFrame. I have a program here, a label with some text and an icon. Its size is 400 pixels wide by 300 pixels tall because of this call right here. If I wanted it to be a different size, let's say 400 pixels wide by 600 pixels tall, then I just change the dimensions. But there's an alternate way to set the size of the frame, and that is instead of calling setSize, to call a method called pack. You do one or the other, not both. What pack does is set the frame to be the minimum size possible to still display all the components it contains at their preferred sizes. You'll notice the borders between the sides of the label and the borders of the frame are non-existent, maybe 1 pixel, 0 pixels. That's not usually what you want. And we can fix that by putting a border either on the content frame or on the label. We'll talk about borders later, but since this is common, let's just do this now. So we'll take our label, we'll call setBorder, and the easiest way to get a border is use the border factory. Let's say 12 pixels on each side. Better. Even with a border, pack isn't always what you want. Sometimes you want some extra space around your components, but sometimes it's exactly what you want. So those are the two options for setting the size of the frame. You'll notice the frame keeps popping up in the upper left-hand corner. If I want to change that, there's really 3 ways to handle it. One is to manually set a location. Let's say 160 pixels from the left edge and 40 from the top edge. There it goes. The second way is to call a method called setLocationRelative2. The idea is, as an argument, we can pass another frame, and it will be centered within that frame or surrounding that frame. But the method is also documented, so if null is what you pass in, it'll center the frame on the screen. Or if you have more than one screen, center it on the main screen. The third way is to call a method called setLocationByPlatform. If you set this to true, you're requesting that the frame be placed as if by the native operating system. On most operating systems, this will cascade the windows slightly offset diagonally down from the upper left-hand corner, but I can't show you that because I happen to be running on a platform for which this isn't supported. However, despite that, I still think setLocationByPlatform true is usually the best way to go. That's our lesson on the size and location of the JFrame. This lesson is on JButton. I've already written a program that pops up a frame. It's a simple matter to add a JButton, new JButton, specify the text to be displayed on the button. Let's create 2 more. Now we need to add them to the content pane of our frame. Add button 1, add button 2, add button. There they are. If we'd like to change the font, we can do that. Set font, font name, font style, size, and let's make it red. Let me also disable button 2. Do that by calling set enabled false. Button 1 is in our italic red font. Button 2 is grayed out. If I roll over the mouse into button 1, I get a visual indication on the border, but on button 2 I don't because it's disabled. Let me take a minute to demonstrate how buttons work. So if a button's enabled and I roll over and I push down the mouse button, the button becomes armed, and if I now let go of the mouse button, that counts as a button press, and whatever actions are attached to this button will occur. But if I roll over, and while continuing to hold the mouse button down, drag the arrow off, the button is still pressed, but it's no longer armed. And if I let go of the mouse button, it doesn't count as a button press. But if I roll over, press to arm, while holding, drag the arrow off, and then I drag it back, it's armed again. If I let go, that counts as a button press. These visual indications are partially functions of the border of the button. If we were to set another border on the button, it'll accept our border, but in addition to being the wrong size, it will not give any indication of rollover anymore. So it's a bad idea to set a border on a button because it will replace the magic border that reacts to events. If you really need to put a border around a button, you can put the button in a panel and put the border on the panel. Notice that button 3 is wider than button 1 and 2. If we wanted them to all be the same size, probably the best way to handle that would be to use a layout manager that sets them that way. But there's another way. Every component, including buttons, has a method called setSize, which we shouldn't call. This method should only be called by the layout managers. But there's another method called setPreferredSize, which is perfectly fine to call. And we could specify a specific size in here, but since we want the size of button 1 to match the size of button 3, the easiest thing to do is just say button3.getPreferredSize. Let's do the same thing for button 2. Now all 3 buttons are the same width. Some look and feel support mnemonics. A mnemonic can be used to press a button not from the mouse but from the keyboard. Some look and feels do not support it. If we want to use Alt-O on this button, Alt-T on this button, Alt-H on this button, for look and feels that support it, here's what we can do. Set mnemonic, character O. Doesn't matter if we give it lowercase o or uppercase O. T, H. Now if we run this, we'll see it's partially worked. Button 3 looks great with the mnemonic indicator under the H, but button 1 and 2, instead of putting the indicator on this T, instead put it on the first T in the string. And same for button 1. We can fix that by manually specifying which mnemonic index should be displayed. We want 0, 1, 2, 3, 4, 5, 6, 7. Position 7 for both these buttons. Button 1, set, displayed mnemonic index 7. And now the indicators are positioned where we want them. The last thing I'd like to show you is how to set a default button for this frame. A default button is a button that will be activated just by pressing the return key or enter key on your keyboard. Most look and feels will decorate it slightly differently also. You've probably seen a default button on an OK or cancel dialog, for instance. Let's say we want button 3 to be the default button for this frame. What you do is you call getRootPane on the frame, and then on the root pane you call setDefaultButton. You'll see that it's decorated with a slightly thicker border, and now if I hit return on my keyboard, you'll see that it presses. This lesson is on buttons with images. I've written some code that pops up a JFrame, so let's add some buttons with images to it. It works very similarly to adding images to JLabels. Create a button, new JButton, and here I give the text I want to appear in the button, and here I give an icon. So I put some images in a folder called JLFGR located in the same spot as my class files. So I'm going to say new image icon, get class, get resource, JLFGR. Let me add 2 more buttons. And let me add the frames content pane. And there they are. By default, the text comes to the right of the icon, but we can change that. Let's put the text below the icon. We'll set the horizontal text position to be center. Set the vertical text position to be bottom. Let's do this for the other 2 buttons. Now the text is below the icon. Those icons look a little small in this orientation, and I have larger ones in that same JLFGR directory. Let me change to those. While I'm here, let me do a couple things to this last button so I can demonstrate how they work. First thing I want to do is turn off the focus indication. And the second thing I want to do is set some tooltip text. Okay, the icons are bigger. Now this rectangle around the icon and the text is the focus indicator. Some LNFs don't even have a focus indicator. But if you'd rather get rid of it, you can do what I did to the paste button so that it doesn't show up. Let me hover the pointer over this button and the tooltip text will appear. Tooltips aren't just for buttons. They can be set on any J component. If I want the buttons to have images but no text, it's a simple change. Just call the JButton constructor that takes an icon without the string. I'd like to show you another way to get images onto buttons using a swing concept called action. Action is more general than just images. First thing I want to do is import another package that I'm going to need. java.awt.event. And now I'm going to create an action class. I'll create it as an inner class, but it wouldn't have to be. It could be a top-level class. We'll call it beep_action and have it extend abstract action. Abstract action is an abstract class that implements the action interface. And it also is declared to be serializable. So to be polite, we should provide a serial version UID. There's 2 things we need to do in this action class. First is to set up some properties. We'll do that in the constructor. And the second is to provide an action perform method as required by the action interface. This method will be called when the button is clicked. So what an action class does is encapsulate the properties associated with an action with the actual action itself. For beep action, we'll just make a beep happen. The constructor will set properties. We use a method called putValue. Name is a constant defined in the action interface, and it defines several more, including mnemonic. On the previous lesson, you could put a character like this. But this is a bad idea because this property is defined to be an integer property, and so we don't want to provide a character. What we want to do is provide a virtual key code constant that's defined in keyEvent class. KeyEvent, VK for virtual key code, and then B for the B key. And this will be autoboxed from an int to a Java lang integer. We could also set a displayed mnemonic index property. In our particular case, we don't have a need for this. And we can set up some images. So there's 2 constants defined. One's called small icon, and one's called large icon. The idea is that if you specify a small icon and a large icon, that buttons will use the large one and menus will use the small one. Or you can just specify the small one, leave the large one out, and then everything will use that one. So let me specify an image icon using one of those images in the JLFGR directory. New image icon, get class, get resource, JLFGR. There's also property keys for short description and long description. The idea is the short description will be the tooltip text. And the long description isn't used for anything. So you can use it for documentation purposes if you'd like. There's also a property constant defined for action command, which we don't need here. We'll discuss action commands in a future lesson. So there's our beep action class that encapsulates this action of beeping. We want to create a button with it. Say button, new JButton. And we give it a single parameter, which is the action. And this will configure the button's text, the button's mnemonic, the button's tooltip, the button's icons. And there it is. I want to elaborate on this a bit. Using the JButton constructor that takes an action does more than just configure the button from the action. What it does is register the button as a listener on the action. And what that means is that if the properties of the action change in the future, then the button will be notified and can adjust itself accordingly. Let me just demonstrate that artificially by changing some of the properties after the call to the constructor is completed. So I can say the action put value siren. And I can say the action set enabled false. Now there's no point in doing it this way. The point is sometime in the future, some method somewhere could change the properties of this action, and that would change the button dynamically. So it's been disabled and the text has changed. It can be smart to use actions as an organizational tool, even if you're not interested in putting images on your buttons. This lesson is about customizing button appearance. You can make a JButton look like anything you'd like, so long as you have an image or an icon for how it should look. I've written code to pop up a frame and put a stock button on. Let's create another button called a round button. Okay, to start off, I won't give it any text, and I'll give it a pink ball icon. Ball icon is a class we wrote in an earlier lesson. Now let's add it to the frames content pane. There's the pink ball, but it has a border, and it has this focus indicator, and it has this background. We need to turn all those off. Turn off painting the border. Turn off the focus indicator. And we'll turn off filling the content. Okay, better. But you'll notice when I roll over the arrow, we get no feedback. And if I click on it, this one gives me feedback. But if I'm clicking right now, you can't even tell. So what we need to do is provide alternate icons for those states. Set rollover icon. Now I'm just going to make a different color ball. But if the art department gave you images, you'd say, okay, give me an image for when it's unselected, give me an image when the rollover happens, give me an image for when it's pressed. Set pressed icon. So this is working pretty well. Get a rollover feedback, get press feedback. Let me temporarily disable this button. This is actually a little darker than it was before, but it's really hard to tell. What we should do is provide a disabled icon. There, and that really looks disabled. There's actually 3 other icons we could set, but they're pointless for non-toggle buttons, and JButton is not a toggle button. But let me list them for completeness. The selected icon. So if you had a checkbox, the regular icon would look sort of like a box that was unchecked, and the selected icon would look like a box that was checked. And this is the rollover selected icon. What should the button look like if it's selected and then you roll over? And similarly, there's set disabled selected icon. Again, these 3 won't make any difference for JButton. What if we want to add text to this round button? Well, we can do that. Use the 2-argument constructor, but then we want to position the text in the middle of the button. We'll say round button, set horizontal text position, center. Same thing for the vertical text position. And there it is. So you can make a JButton look like anything you'd like. This lesson is on reacting to button clicks. I've written a program here that has a status label and 2 buttons, but the buttons aren't attached to anything. So if I click on them, nothing happens. We saw earlier how to do this with an action class, and actions are great. Let me show you some other ways to react to button clicks. So if I want button A to do something, call button A, add action listener, and between the parentheses here, I need to specify an action listener. The easiest way to do that is to provide a lambda expression. So E is the action event, and we can just print it out. Let's add an action listener for button B. Again, we'll use a lambda expression, and let's set the color of the status label. Set foreground color.red. Okay, let's try it. Press button A. See down at the bottom that I get my print line. Now I push button B. The status label turns red. You can add as many listeners as you'd like to each button. So if I want to add another one to button A, like this, it'll work fine. You'll notice the print line from the second action listener appears first. The spec actually does not guarantee any particular order, but in all versions of Swing so far, it's always performed the most recently added action listener first. These lambda expressions work great for small, simple things, but if you want to do something more complicated, what I like to do is just call a method. So let's call the method handleB. So the lambda expression will call the handleB method, and all we need to do is write that method. Now a problem is that status label is a variable local to the startup method. And since handleB is a different method, we're not allowed to refer to it. That's easy to fix. We'll just move the declaration from startup and make it a field in our class. It works. You'll notice when I click A, it prints out information about the event, including modifiers equals button 1. But if I hold down the control key, which I'm doing right now, and then I click on button A, you'll see it's added this control plus button 1. So let me show you how to detect that. First of all, our handler method needs access to the action event. So we need to go up here and pass it in. And now we can say if get modifiers. Now this method returns a bit mask. And so let's use the bitwise AND operator to check if the control key is down. So we use control mask. Let's see if that is equal to the control mask. So if it is, let's change it to a different color. So now what this method will do is it'll check if control is held down, and if so, it'll set it black. Otherwise, it'll set it red. So here I'm going to just press it without holding control down. It turns red. Now I'm holding control down. I'll push it again. Back to black. Let me write a different handler method to demonstrate an important point. And that is that these event handlers are called on the event dispatch thread. Let's say I want the result of my button press to be something that takes a long time. So for instance, I have a method that I've written here called numberCrunch, and it just returns a constant value, but it sleeps for 5 seconds to simulate something that takes a long time, like a database access, some other network I/O, or maybe just some tricky computation that takes a lot of computational cycles. And so you might be tempted to do this, which is to take the status label, set some text to say that, hey, I'm thinking about it, and then to call this numberCrunch method, and then to set the status label to the result. But this is bad. The event dispatch thread needs to be able to react to all the user events. And if we call numberCrunch or otherwise lock up the thread, it won't be able to do what it's supposed to do. So this is bad. Well, let me show you what happens. Now before I press button B, notice that I get visual feedback from mousing over A, and if I resize the frame, it does so smoothly. Now I'm going to push button B. Notice there's no dots here, there's no visual feedback, and resizing the frame doesn't work until the computation is done. So the 42 is here, but we never saw the dots. What happened was all those user events, like mousing over, changing size of the frame, couldn't be processed during the number crunch. And so they just got queued up, and they didn't happen until the number crunching was done. You don't want to write applications that do this. But Swing provides a class called Swing Worker. And the idea is this. You create a Swing Worker, we'll customize it inside these braces, and then you execute the Swing Worker. This is important. If you don't call execute, then the Swing Worker won't do anything. And now we implement two methods. One's called doInBackground, and this will be called by some other thread, not the event dispatch thread. And so here is where we do our number crunch, and we return the result of the number crunch. And then the other method we override, called done. And this will be invoked when the doInBackground is complete, and it will be called from the EDT again. So what we'd like to do here is call get, which will give us the value computed in doInBackground, and then set it into the status label. So it's really as simple as this, except for this get method, unfortunately, throws some checked exceptions. And so we have to handle that. Interrupted exception will happen if the doInBackground method gets interrupted. And there's another one we need to catch, execution exception. And this will be invoked if the doInBackground method throws some other exception. Let's just rethrow that as a runtime exception. We'll call getCause on the execution exception to access the underlying exception that caused the execution exception to be thrown. So again, we set the dots onto the status. We execute a swing worker that calls number crunch in doInBackground on some other thread, and then takes the result of the doInBackground and sets that into the status label on the event dispatch thread again. So let me press button B now. There are the dots. Here's the feedback. It's crunching right now, and now the 42 shows up. So this is the right way to handle a situation like this. Let me explain what these two type parameters are for swing worker. This first one, let's change it to string, is the type that doInBackground returns. Let me change this to a string here. And now this has to be a string. Get will return the same value type that doInBackground does. Swing worker has some functionality which we're not using here to be able to display to the user updates in the middle of the computation done in doInBackground. And since we're not using that, I specified that type as void. But if we were using that, this would be the type of these intermediate values that we want to handle. There's one last thing I'd like to show you, and that is what to do if you're running in Java 7 or earlier where Lambda expressions are not permitted. We have to provide an argument of type ActionListener to this method. And one way to do that is to declare this class as an action listener. So we'll specify this as our action listener. We'll declare that the button reaction class implements the action listener interface. Action listener interface specifies that the method is called actionPerformed, which takes an action event. So this satisfies that interface. This has been our lesson on reacting to button clicks. This lesson is on the JToggleButton class. Let's create a JToggleButton. Let's create a standard JButton for comparison. And we'll add them to Frames content pane. Now they look the same, but a toggle button, when you click it, stays depressed until you press it again. If you want to add an icon to a toggle button, use the setIcon method to specify the icon you'd like the button to display in its deselected state. So you might want to choose something that looks sort of disabled. So let me put all icon in light gray. Then also set a selected icon. And say the color green. So this has a nice look to it. Let me rename it mute. And let me also give it a second argument, which will be the initial selected state. So if I want the button to be selected when the program starts up, I'll put a true there. So the mute's on, mute's off. If you want to add a listener to the button, you can call add action listener the same way you would with the J button. And here you specify an implementation of the action listener interface. But for toggle buttons, it makes more sense to add an item listener. Then in parentheses, you specify an instance of the item listener interface. We'll use a Lambda expression. E here, instead of being an action event, will be an item event. Let's create a method called handleToggle. This method will be invoked whenever the button changes state from selected to deselected, or from deselected to selected. If you'd like to know which one, you can call getStateChange. This will return an integer depending on the selected state. So you use it like this. If it's selected, so if we click this, it says below mute is off. If I click it again, mute is on. Querying the item event is one way to find out what the selected state of the button is, but you can also just ask the button. So as an example, let me set an action listener on the stock button. So now we'll just ask the toggle button if it's selected by calling the isSelected method. So we'll return true if the toggle is selected and false if it's not. So if I click this, muted state is true. If I turn off the mute and click this button, muted state is false. People don't use JToggleButtons all that often, but it does have two subclasses, JCheckBox and JRadioButton, that are used frequently. We'll look at those in upcoming lessons. This lesson is on the JCheckBox class. Let's create some JCheckBoxes, but first I want to create a JLabel to put at the top of the frame. There are that options. Let's create some JCheckBoxes. JCheckBox is spelled with a capital B. Sometimes I forget to do that, and I have to go back and correct it. New checkbox. And here I'll put the text I want to accompany the checkbox. Well, let me make 4 of these. Specify some clarinet options. Now let me create a standard J button for placing the order. I need to add all 6 of these J components to the frame's content pane. Option 1, option 2. So we can run this program and see our checkboxes. There they are. In some look and feels, you can click on the text and it will toggle the check. Some look and feels, you would have to actually click on the box. Now let's add an action listener to the Go button. We'll make a function called place order. Now I could pass in the action event as a parameter, but in this particular case I won't need it, so I'll leave it out. Now in order to place the order, we want to know the state of the 4 checkboxes when the form is submitted. So we'll do something like if option 1 is selected, then do something. But option 1 and the other J checkboxes are declared to be local variables in the startup method. So let me just move those, make them members of the class, and then we can refer to them in this place order method. In the real world, you would take information about these 4 options and create a real order with it by submitting it to a database or calling some method. But for demonstration, let's just use some strings. So I'll create a string builder. For each selected option, we'll append to the string builder. And we'll do that for the other options too. But we want to put a separator into the string builder if option 1 and option 2 are selected. So one way to do that is to say the length of the string builder is greater than 0 and append our separator. If none of the 4 options are set, we might want to specify a special string for that. And now we'll just print this. Click with no options, it says none. So this is a typical form submission with checkboxes. Let's say you have a situation where you want 2 of the options to be forced together. So they're either both on or both off. One way you could do this is you could add item listeners to the 2 checkboxes and listen to one and set the other one. But there's an easier way. Each button class in Swing has an underlying button model. And the button model keeps track of the state of the button. Is it armed? Is it selected? Is it enabled? And what we can do is have 2 of these J checkboxes share the same model. So if I want option 1 and option 3 to be tied together, I can say something like option 3.setModel. This sets the button model and pass in button 1's model by calling option1.getModel. So now if I click the first option, the third one will come in also. If I undo one, sometimes you might have a real situation where you need to do this. But the primary reason I mention it is just because I want you to be aware of button models. There's one last thing I want to show you, and that is you have to be careful if you set an icon on a checkbox. So let me do that. Now you notice my light gray icon is here. But the problem is If I click on this, which I'm doing right now, but you can't tell because it uses the same icon for both deselected and selected. Unlike this one, where the selected icon looks like a box with a check in it, and the deselected icon looks like a box without a check in it. It's a mistake to call set icon on a JCheckBox without also calling set selected icon. This also applies to JRadioButtons, by the way. So let me set the selected icon. In this way, the user sees feedback about the state of the checkbox. This lesson is on JRadioButtons and button groups. I've already written a program that declares 2 labels, 8 JRadioButtons named X1, X2, X3, X4, X5, and int1, int2, int3, and a JButton for placing an order. And I've already placed them on the frames content pane. So let me run this program I've written. The key thing to observe is these JRadioButtons behave exactly the same as JCheckBoxes. The only difference is the icon. The radio buttons get round-looking icons, while the JCheckBoxes get squarish ones. And if I click on one, it gets a dot instead of a check. But by default, if I click on a selected JRadioButton, it deselects, just like a JCheckBox. And I can turn all of them on. This default behavior is not what most people want with radio buttons. And the way to get the behavior that you expect is to use a button group. In fact, we'll use 2 button groups, one for the exterior choices, one for the interior choices. So we'll create a button group called button group, not JButton group, because it's not a component. It's just a utility class. Only the swing components get the J initial letter. Equals new button group. Once we have one, we can add our buttons to it. Do the same thing for interior button group. Let's run the program again. Now the 2 things a button group does is if I select another group button in the group, it'll deselect the first one. So at most one of them can be chosen. And the other thing it does is it prevents me from deselecting a selected button. So I'm clicking on this, but it's not deselecting the button group. Once one of the buttons in a group has been selected, there's no way to return that initial state with no selected buttons. In fact, we could force this. Let me set the first interior choice to be on by default. Now, there's no way to undo this. No matter what, there'll be an interior choice. Now let's implement an action listener for this place order button that determines which choices have been made by the user. Add action listener. One way we could determine which button in the group was selected is just to ask each button in turn. So we could say if int1.isSelected, then do something else. If int2.isSelected, then do something else, and so on. But it's possible to ask the button group directly which button is selected. Sort of. System.out.println. And we'll call int button group get selection. But if you'll notice on this pop-up here, the return type is not a button. The return type is a button model. So it doesn't return the selected button. It returns the model of the selected button, which is a little bit cumbersome. So if we were just to do this, it wouldn't be very useful. So it says button model at 4C. This one's button model at 63. But what we can do is we can ask the button model for its action command. Now on the face of it, this is worse. Because if I click this, it's just going to say null, null, null. That's because we haven't set action commands for our buttons. But we can simply do that. Set action command. 2.setAction command. 3.setAction command. Now if I click this, cloth. It's black. This one natural. So this is probably the easiest way to determine which button in a group is selected. Something you have to be careful of, though, is that you can get a null pointer exception. So if I allow there to be no selection, when I click this, null pointer exception. The reason is that this getSelection method returns null, and we're trying to invoke the getAction command from that. So one way to fix that is called a placeOrder method, and write a placeOrder method. And then we can get the selected button model. To do this, we have to take interior button group from being a local variable in the startup method to being a field in the class. And while I'm here, let me set some action commands for the exterior choices. Spell that correctly. And now I can ask if it's null or not. Get action command. Let's do the same thing for the exterior. No exterior selection, no interior selection. So we get our interior selection. Before we go, let me mention that button groups can work with any type of toggle button. So you can add a JToggleButton, you can add a JCheckBox, you can add a JRadioButton, you can add all three to the same button group. The button group doesn't care. In practice, you usually use it with these radio buttons. This lesson is on JFrames content pane. I've written some code that pops up a JFrame, and the way we've been using JFrame is to create components. Let's create a JLabel, and then to add it to the content pane of the frame. There's our JLabel. If I want to change the layout manager of the content pane, I can do that. Get content pane, set layout, and then I give some new layout manager here, say flow layout. You can tell the layout manager's changed because the label is at the top of the frame instead of in the center of the frame. Now I should point out that it's not strictly necessary to call getContentPane for setLayout or for the add method. So if I do this, and we're running on Java 5 or later, Java 5 came out way back in 2004, then JFrame will defer for these methods to the content pane. So this will run. It looks the same. But there's two reasons I don't usually do this. One is that if you happen to be running on Java 4 or earlier, these will throw exceptions. And the other is that frame is a complicated object that has a lot of parts. So the content pane is only one of those parts. And I like to make it obvious that I'm adding these things to the content pane. Now let's say I want to add a border to the content pane. What I'd like to be able to do is call frame, get content pane, set border, and put a border in here. But I can't do this. And that's because the return type of the getContentPane method is container, and the setBorder method is defined in JComponent. The object returned by getContentPane will actually be a JPanel. And if I wanted to, I could cast it to a JPanel. And then I can call setBorder. But this is an ugly cast. It works. There's the pink border, but it's not typically done that way. It's more common to instantiate our own JPanel, like this. JPanel. Let's call it main panel, new JPanel. A JPanel is just an invisible swing component that holds other components. So if I want to add the label to the main panel, I'll just say main panel.add contents. And if I want to set a border on this panel, I'll say main panel.setBorder. There's something important to note though, and that is, by default, the content pane of a JFrame will be laid out with border layout. But by default, a JPanel will be laid out by flow layout. So if we wanted our JPanel to use border layout, we would have to set that explicitly. We could either say main panel, set layout to border layout, or it's really simpler to just pass in a layout manager into the constructor of JPanel. Now to get the main panel onto the frame, we could say frame.getContentPane, add main panel, and this works, but there's needless nesting. Because what we've done is we put the label into the main panel and the main panel into the content pane. And while that works, it's more straightforward to set the main panel as the content pane. So we just say set content pane main panel. So it replaces what had been the JFrames content pane with our pane. This lesson's on flow layout, which is one of several layout managers available to us. Create a JPanel that uses flow layout. The argument to the constructor is the layout we want. Now, if you recall, JPanel defaults to a flow layout and layout manager. So if I wrote it like this, it would be the same. But for this lesson, I want to be explicit, so I'll put it back. And then let's set main panel as the content pane. Flow layout can handle any number of components you want to throw at it. Let's add some components to this panel under flow layout. I'm calling this add method with one parameter, the component that I want to be added. This is appropriate for flow layout. There's another version of add that takes two parameters. The first one is the component to be added, and the second one is a constraints object. So for instance, border layout.center is a constraints object. But flow layout ignores constraints. So there's no point in providing one. In fact, it's kind of confusing to do so. Let me add some more buttons here. What flow layout does is give every component its preferred size. So you'll notice the buttons with longer names are wider than the buttons with shorter names. And it attempts to lay them all out in a single line. So if the panel's wide enough, like this, they all fit in a single line. But if it's not, it wraps to a second line or a third line. If the panel isn't tall enough, components can be clipped or even left off entirely. I should mention that one of the motivations for Swing using layout managers at all is to support dynamic resizing like this. Flow layout defaults to the center alignment, but we can specify a different alignment. Flow layout right. The buttons are pushed to the right side of the panel. If there's more than one row, each row is pushed to the right. Same thing for left. Let me make one of these buttons taller so you can see how flow layout handles components with different heights. Set a larger font here. 48 points. Flow layout handles different heights just by centering them. Let me point out the horizontal gap between these two components right here is 5 pixels wide. And this vertical gap between these two components is also 5 pixels. But if you'd like, you can specify your own values. Second parameter is the horizontal gap, let's say 20 pixels, and the third parameter is the vertical gap, let's say 10. You see the gap between two components horizontally is 20 pixels, vertically is 10 pixels. Note that this not only sets the spacing between components, but also the spacing between components and the edge. This distance between the edge of the frame and button 1 is 20 pixels. And this gap between the top of the frame and button 3 is 10 pixels. This lesson's on border layout. Let's create a J panel with border layout. New J panel. New border layout. Let's set this as the content pane. Border layout keeps 5 slots for components called east, west, center, north, and south. If we want to add a component to the east slot, say add, provide the component, and we'll specify a constraint of border layout.east. Let me set components for the other 4 slots too. Here are our 5 buttons. What border layout does is take north and south and honor their preferred heights, but stretch their width to be the entire width of the panel. Then it takes east and west and honors their preferred widths, but stretches their heights to be the entire height of the panel, less the height of north and south. Then it stretches the center component to fill the entire remaining area in both width and height. So if I dynamically resize this, you'll see west and east remain the same width but change height. South and north maintain their height but change their width, and center grows both ways. Also notice that these components are smashed up next to each other with no gap between adjacent components. We can fix that by specifying a horizontal gap and a vertical gap in the constructor to border layout. So let me set 8 pixels for each one. So now adjacent components are separated by 8 pixels, but you'll notice there's no gap between the edges of the panel and the components. If you want that, we can set a border on the panel. Main panel, set border, border factory, create empty border. These are the widths of the top, left, bottom, and right. Now we have 8 pixel gaps everywhere. Let me point out a couple things. One is, if we don't provide a constraint at all, it defaults to center. See, the center button is still in the center. I prefer to set the constraint explicitly. You need not have all 5 components. So if I want to get rid of east and north, and keep the other 3, it works fine. Each slot can only have 1 component. So if I were to try to set a second component to south, This line adds the south button to south, but this line replaces that south button with the yonder button. So south will no longer be a part of this panel. If you do want more than one component in a slot, you can just create a nested panel. So let me create a panel called South Panel. I'll go to Flow Layout. I can add 2 components to the South panel. And now, South 1 and South 2 will show up in South. We can use the same technique to lay out a single component, but in its preferred size. Let's create a JPanel with grid layout. I need to specify the number of rows and the number of columns. So let's say 2 rows and 3 columns. 2 rows and 3 columns leave 6 spots for components. So let's add 6 components. When I'm adding these components to the panel, I'm not specifying a constraint. Border layout uses constraints to determine which component goes where, but all that matters for grid layout is the order in which they're added to the panel. Okay, let's set this panel as our content pane, and run. There are 6 components, and 2 rows and 3 columns. First 3 components go in the top row, and the next 3 components go in the next row. Notice that all 6 components are the exact same size. Even if I resize the panel, they remain the same size as each other. That's what grid layout does. Let me change it to 3 rows and 2 columns. The shape of the buttons has changed, but all 6 are still the same size. If we want to put space between components, we can specify horizontal and vertical gaps. So let me specify 8 pixels and 8 pixels. You can see the gaps between components, but there's no gap between the edge of the panel and the component. In this regard, grid layout is just like border layout. And if we want a gap around the edge, we can do the same thing we can do with border layout, which is to set an empty border. Let me explain what happens if we don't use all the spots. So let's say I only have 5 components that I add to this grid layout with 6 slots. Not surprisingly, it just leaves one off. The 5 components are the same size as each other, but there's a hole here. But what might be surprising is that if we add an extra component, it creates a new column. It has the 3 rows we asked for, but instead of the 2 columns that we've asked for, it has 3. That's because the way grid layout works is if you specify 3 rows, you get 3 rows no matter what. It'll just take the number of components that have been added, divide it by the number of rows that have been set, and that determines the number of columns. So in this case, we have 7 components. 7 divided by 3 is greater than 2, so it rounds up to 3 columns. In fact, you might as well put a 0 for the number of columns. What this means is there'll be 3 rows, and just take as many columns as you need, which is grid layout's behavior, no matter how many columns you specify. So with 7 components, I'll get 3 columns. With 6 components, I'll get 2 columns. With 4 components, 4 divided by 3 is greater than 1, so it'll round up to 2. We'll have 2 columns. Because we specified 3 rows, there are 3 rows, 1, 2, 3, but in this particular case, the 3rd row is empty. If you'd like, you can specify a 0 for the number of rows, but then you have to set something non-zero for the columns. So let's say I say 1. This says there should be 1 column and as many rows as you need. That's our lesson on grid layout. This lesson is on using compound layouts. There are several layout managers that come with the JRE. 3 we've talked about so far are flow layout, border layout, and grid layout. I use these 3 layout managers all the time. There's also a layout manager called box layout. It can be set in horizontal orientation or in vertical orientation. The horizontal one is similar to flow layout or a grid layout with 1 row. And in vertical orientation, it's similar to a grid layout with 1 column. The key difference is in box layout, different components can be different sizes. Grid bag layout is a layout manager in which you assign very complicated constraints objects onto the components you add. It's possible to code group layout and spring layout by hand, but most people don't. They were designed to be used by code generation tools, not by human coders. Card layout and overlay layout are technically layout managers. Card layout will show one at a time and you can flick between them. Overlay layout will just place them on top of each other. And finally, you can write your own layout manager. It's not very hard. Or if you look around, there's lots and lots of third-party layout managers available. So what I'd like to do in this lesson is show how I can combine different layout managers to create a more complicated layout. Here's some components that are laid out by some graphics manipulation program. we'll try to simulate this layout in Java Swing. There are many approaches we could take to do this. We can take the buttons on the right and set them in the east side of the border layout and put everything else in the center. Then we can further subdivide each of these two panels. On the right, we'll put a panel in north to hold the 3 buttons. That's the only thing we need on that side. On the left, we'll put this pixel dimensions panel in the north and everything else in the center. And then we'll further divide up the center with 3 panels. The document size components in the north, the checkboxes in the center, and the resampling combo box in the south. If you look at the pixel dimensions panel, there's 4 parts. There's the labels, width and height. There's the text boxes that are holding the numbers. There's the combo boxes that are holding the pixel pull down. And there's this locking button to the right. So one way to handle this is put the locking button on the east and everything else in the center. Now if you look at the center, you could almost use a grid layout with 2 rows and 3 columns. But I'm not going to do that. And that is because grid layout will force all components to be the same size. But I don't want that. I want the labels to be a little narrower or the text boxes to be wider. So I can split this up into a west panel, center panel, and an east panel. If you've been keeping count, we have well more than a dozen panels now. But that's fine. That's what panels are for. Most of these panels have 2 or 3 components in one column. So a simple way to lay those out is just use grid layout for all 8 of those. That leaves only these 2 locking buttons, which will lay out nicely using flow layout. I have some code that pops up a frame. I've also declared some string arrays that I'm going to need later. Let's set the content pane to something called outer panel. Give us a border layout. Let me set 8 pixel gaps. And then I'll add something called east panel to the east. And let's call everything else settings panel. Those are the first 2 nested panels. So let's make east panel. Border layout again. And to that, we'll add something called button panel to the north. Button panel will use grid layout. 0 rows mean as many rows as needed, 1 column. And let me set some gaps between the components. Now we just add our 3 buttons to the button panel. Let me comment out this line so we can take a look at what we have so far. Here's our 3 buttons on the right. They're right against the edge though, so maybe I should set an empty border around the edge of the outer panel. Better. So let's create the settings panel. And we'll add that pixel dimension to the north. I'm going to create a helper function to create this panel for me. So let me call that create dimensions panel. And to the center, we want to add the rest of the settings. So let me call that inner settings panel. Okay, to the north goes our document size panel. So let me call another helper function for that. Create document goes in the north. Checkboxes go in the center. And the combo box goes in the bottom. Let me create the 3 checkboxes by using this as a template. Before I can run this, I need to create these 2 helper functions. Return a JPanel. Let me just create a placeholder for now so we can run the program, see what it looks like. This will be our placeholder. I'll just return that panel. Copy this for our document panel. So we're getting there. We have our 3 buttons. We have these placeholders. We have our 3 checkboxes and our combo box. There's too much space between the checkboxes, but when the placeholders expand, that won't be a problem. I think I'd like a little more space to the left of these buttons. Specify 20 pixels there. Let me correct the options for this combo box. Better. I'll set these 3 checkboxes to be on to match our template. Now I'll implement this Create Dimensions panel properly. Create 3 panels. One on the west should contain the labels. One in the center to hold the text fields. One in the east to hold the combo boxes. This is our first label. This is our first text field. And for the second row, we'll alter this. Height 900. Put these 3 panels inside another panel. Add the west to the west, the center to the center, the east to the east. Need to create a panel for the lock toggle button with flow layout. And add the button. Instead of the placeholder, we'll put the main panel. In the east, we'll put the lock toggle button. That looks about right. I want to make this button taller to match the template. I can do that by setting its preferred size. Now we need to do the same thing for this document size placeholder. So I'm just going to cut and paste everything I wrote for the dimension panel. And fix the contents of these text fields and combo boxes. And add our third column. There we go. A pretty decent implementation in Swing of our template. That's our lesson on using compound layouts. This lesson is on borders. I've written a program that takes 1 button and 7 labels and lays them out in a 1-column grid layout with 20 pixel gaps between the rows. Here's what it looks like. We're going to set various borders on these labels, but there's 2 things I want to point out. The first is that this button is right up against the borders of the panel. And the other is that the button already has a border. And in fact, it's the border that is reacting to these mouse over events. So first, let me put an empty border around the main panel. Border factory, create empty border. 20 on the top, 20 on the left, 20 on the right, 20 on the bottom. That will create some space between the edges of the pane and the button. Now let's say I set a border on the button. So let me just create a 0-pixel empty border. So there's an empty border all the way around the frame, but by setting an empty border on the button, we've replaced the border that reacts to the mouse over. So I'm getting no feedback at all when I mouse over. I point this out because some components already have borders that are integral to the component. Button is the most obvious example, but text fields also do. And if you want to replace their borders with your own borders, that's fine, but sometimes you lose functionality, especially on the J button. If you want to put a border around a button without replacing its existing button, you can just put the button in a panel. So let's create a panel with a border layout. Let's put a button in there. And now, since comp 0 is the panel, we'll put a border on the panel. There's an orange border on the panel that reacts to mouse overs. When I create borders, I almost always use Border Factory. But you don't have to. You can instantiate the borders directly, but they're in a different package. So I can say import javax.swing.border.star. And now right here I can say new line border. But there's really no point. I just use Border Factory. In fact, Border Factory sometimes caches borders so they can be reused. So let me set borders on these first 3 labels. Border Factory, create etched border, set border, Border Factory, create raised bevel border, set border, Border Factory, create lowered bevel border. You see the etched border, nice clean look to it. The raised bevel looks like it's popping out of the frame, and the lower bevel looks like it's popping into the frame. But if you look closely, you'll see all they've done is flip the darker color on the top and left, and the lighter color on the bottom and right. So on the raised, the lighter colors on the left and top, and the darker colors on the right and bottom. If you'd like, you can provide parameters to these border factory methods and provide your own colors. You'll see this 2-parameter method here takes 2 colors for etched border, and the same thing for the bevel border. If I use this method, I can specify the type, either raised or lowered, which is a constant defined in bevel border, and the bright color and the dark color. But there's another feature of etched and bevel borders that I'd like to show you, which is they respect the background color of the component they are placed on. So if I call lab1.setBackground red, lab2 set background color.green, lab3 set background color.magenta, setting the background color of a label won't have any effect on the actual label because by default a label's background is transparent. But notice the etched border and the bevel borders change their coloring to match the background color of the label. Let's try some other types of borders. For this one, we'll set a titled border. Border factory, create titled border, give it some string. By default, it places the title above the component with left justification right on top of the border. But if you look at the options available, it's possible to set justification left, center, or right, and the position to be either below or above the component. And then once you've decided that, either right on the border, right above the border, or right below the border. It's also possible to put this title on any style of border by passing in this first parameter to be the border you'd like to put it on. So you can create a beveled border with a title on it by just providing the first parameter as a beveled border. Okay, line border. By default, a line border has a thickness of 1 pixel. We've seen one of those earlier. So let's set a thicker one this time. Let's say 15 pixels. There it is, line border. Matte border is a lot like line border, except for you can have different dimensions for the top, left, bottom, and right. For instance, I could say 5 pixels on the top, 10 pixels on the left, 15 pixels on the bottom, and 20 pixels on the right. It results in this very funky looking border. You probably wouldn't actually do this in a real program, but one thing you might do is give one width for the left and right, and another width for the top and bottom. There's another thing that matte border can do, which is to tile an icon instead of to use a solid color. Create matte border. So let's say 15 pixels on each side. Instead of specifying a color, you can specify any implementation of the icon interface. We can instantiate a new ball icon with 15 pixels and let's say green. And let's tile this in the border. It looks pretty snazzy, but you have to watch out. It's just by luck that this came out this nicely. Watch what happens when I resize this. The left and the top will always look good because it's 15 pixels wide and the icon is 15 pixels wide. But you're sort of at the mercy of the size of the component for what happens on the right and the bottom. There's one last thing I'd like to show you about borders, and that is that it's possible to put more than one border on a component. We'll call border factory create compound border. And this takes 2 borders, an outer first and then the inner. And you can specify any borders you'd like. So for the outer one, let's choose bevel border. And for the inner one, let's choose a line border. So here it is. There's a bevel border and an orange border, but they're smashed up against each other. So we'll keep the bevel border for the outside, and then for the inside, we'll create another compound border. Create an empty border, let's say 5 pixels, and then the line border will be the inside border of the inside border. It looks like this. That's our lesson on borders on components. This lesson is on JScrollPane. For motivation, I've created a method called createButtonPanel that returns a JPanel containing a number of buttons in a single column. So let me call this method, let's say with 15 buttons. And let's add this to the main panel. There are the 15 buttons, but they're compressed vertically in an unflattering way. If the frame were taller, then the buttons would look better. But if we prefer to leave the frame the same size and we want the buttons to look okay, we could put the buttons inside a scroll pane. Instead of adding the button panel, we'll add a new scroll pane and pass the button panel as a parameter to the constructor. Now the buttons are laid out in their preferred height, and we can scroll to get all of them. If I resize the frame narrower, it creates a scroll bar here on the bottom. Any component can be placed inside a scroll pane. We just did it with the J panel. But some swing components are almost always placed inside a JScrollPane. The design of these components assumes that they'll be placed inside a JScrollPane. The components are JList, JTable, JTree, and the multi-line text components, JTextArea, JTextPane, and JEditorPane. So if we have a JTable, we shouldn't add the table directly to a panel. Instead, we put the table inside a JScrollPane and add the JScrollPane to the panel. Notice that where the scroll bars meet, there's this empty square. It's actually possible to put a component into that square. First, I'll move the scroll pane out to its own variable so I can access it. Now let me create a button to put in that corner. Now I'll add this button to the corner of the scroll pane by calling the setCorner method of JScrollPane and specifying the lower right corner. Now look, the corner isn't displayed, so our button isn't visible. If I make this narrower, there's our button. If I click it, it says corner. But if we want the button to be visible from the start, we can do that. JScrollPane has two methods called setHorizontalScrollBarPolicy and setVerticalScrollBarPolicy, which can be used to tell the scroll pane to always show those scroll bars. I set these to horizontal scroll bar always and vertical scroll bar always. You could also say horizontal scroll bar never, vertical scroll bar never, or horizontal scroll bar as needed, vertical scroll bar as needed. Now if I run this, the button is there from the beginning. That's our lesson on JScrollPane. This lesson's on the JSplitPane class. I've written some code that pops up a panel. Let me create two J panels to put in the split pane. Defaults to flow layout. Put a button in the panel. That's the first panel. Let's make the second one. Now let's create the JSplitPane. New JSplitPane, it takes three parameters. The first one is either vertical split or horizontal split, which determines the orientation of the divider in the split pane. So let's say horizontal. And now we'll give the left component, we'll put it in the first panel, and the right component. Just need to add the split pane to our main panel. There's our split pane. We can drag the divider. That's really all you need to know about JSplitPane, but I'll show you some further details. There's an option you can set called One Touch Expandable. So let's turn on that option. Now exactly how this looks depends on the look and feel, but usually it'll decorate the divider with these little buttons. And if I click on it, it closes all the way. So if you want your split pane to have that feature, then just turn it on. If you'd like to programmatically set the location of the divider, you can do that. Let me put some action listeners on these buttons. When the user clicks the first button, we'll call splitPane.setDividerLocation and give it an integer, which is the number of pixels from the left or from the top. But if the user presses button 2, we'll call splitPane.setDividerLocation and give it a floating point number. By setting it to 0.75, that means locate the divider 75% of the way through its range. Before running, let me change this to vertical split so you can see what that looks like. Here's our vertical split. So the first panel's on the top, the second panel's on the bottom. If I click the first button, it'll move the divider to 75 pixels. If I click the second button, it'll move the divider to 75% of the way down. When I drag the divider, notice what it's doing. It's not moving the second panel or the first panel as I drag this. It waits until I let go of the mouse and then does it. There's an option to change that. Set continuous layout. Now when I drag the bar, it lays out the panel smoothly. I'd recommend you turn on continuous layout most of the time. The only situation in which doesn't make sense is if what you're laying out is very complicated. So you had a table with a lot of entries, or you had a component that did ray tracing or something like that. When I drag this up, even though I haven't released the mouse and I'm moving the cursor upwards, it's not moving the divider further. That's because the JSplitPane honors the minimum size of its components. And the minimum size of first panel is the minimum size of the button. Some components have large minimum sizes. Objects and scroll panes often do. And sometimes you'd like to be able to get around this. So what you can do is set a minimum size on these components. Let's say 4 pixels by 4 pixels. Now when I run, it will let me raise this until it gets to 4 pixels. Let me undo that. There's one final thing I should mention, and that is you have to be careful when setting the divider location when you're doing the layout. So let's say right here, just after I've instantiated the JSplitPane, I say set divider location 75 pixels. It's located at 75 pixels. If I say set the divider location to be 75% of the way, it's not going to work. And the reason is, at the time this call occurs, the split pane hasn't been laid out yet. So if you want to set divider location here, you have to do it in pixels. 165 pixels is about 2/3. So if we try this, it should look right. That's our lesson on JSplitPane. This lesson's on JTabbedPane. I've written a utility function called createRadioPanel that, given a number of strings, will create a JPanel with that number of radio buttons in it. And I've called it 3 times here. So eggs panel will be a JPanel with 3 radio buttons. And bread panel will be a JPanel with 4 radio buttons. Meat panel will also have 4 buttons. Let's create a JTabbedPane to contain these. Then we'll add each tab individually. First, we provide the text that will be displayed on the tab. Then we specify a single component to occupy the tab. There are the 3 tabs. All we need to do now is add the tab pane to the main panel. This is our JTabbedPane with 3 tabs. One for eggs, one for bread, one for meat. Let me show you what happens when there's not enough room for the tabs. By default, we'll create multiple rows of tabs, but there's an alternate setting that we can enable. Set tab layout policy. We'll scroll tab layout. Now if there's not enough room for the tabs, we'll create these scroll buttons. It's also possible to move the location of the tabs from the default location on the top of the JTabbedPane to any of the other 3 sides by calling set tab placement. So let's try the left. The tabs along the top or the bottom look a lot better than tabs on the left or the right. The tabs, in some ways, behave like buttons. And in fact, it's possible to define button-like properties for each tab using methods that end in the word at. So for instance, I can call tabPane set icon at, and first I give the index of the tab that I want to set the icon on. So index 0 would be the eggs tab, index 1 would be the bread tab, index 2 would be the meat tab. And then I can specify the icon here. Or I could call set mnemonic at, set displayed mnemonic index at, set tooltip text at, set enabled at. So if I wanted to disable a tab, I can do this. The last tab is disabled. If I click on it, nothing happens. There's 2 things I'd like to show you how to do with JTabbedPane. One is how to programmatically change which tab is the selected one. And the other is to detect when the tab selection changes. So let's programmatically change the selected tab first. So let me create a button and add it to the eggs panel. Let me add a listener to the meat button. This action listener will call tabPane.setSelectedIndex or setSelectedComponent. If I call setSelectedIndex, I give the index of the tab I want. And since the meat tab is at index 2, this will do the job. Or I can call setSelectedComponent, where I give it the component that I want to be active. In this case, that would be the meat panel. Either one of these will work. Now when the user clicks the meat button, the tab pane will change over to the meat tab. Okay, how do we detect when the user changes tabs? You might have an application where when the user clicks bread, you want to be notified. When the user clicks eggs, you also want to be notified. The way to do that is to add a change listener to the JTabbedPane. When this change listener is called, it's probably the case that the tab selection has changed. Let's set the text of the top label. Get selected index. Now when the user clicks a tab, this label will change. Index 1, Index 2, Index 0, Index 2. That's our lesson on JTabbedPane. This lesson's on JMenu and JMenuItem. I've written a simple application that just shows a label. Let's add a menu to this application. First, I want to create my JMenuItems. JMenuItem has the same parent class as JButton, the class named AbstractButton. So you can do a lot of things to a JMenuItem, such as adding an action listener. Let's create another JMenuItem. Once we've defined our JMenuItems, we need to add them to a JMenu. So let's instantiate a JMenu, and then add each JMenuItem to the JMenu. Then we need to add this JMenu to a JMenu bar, and then add the JMenu. Finally, we need to add the JMenu bar to the application somehow. Here's how not to do it. You might be tempted to do this. Add it to the main panel like you add any other component. In fact, this is legal, but it's probably not what you want to do. There's a specific method for that called setJMenuBar. So here's our menu. If I choose the wheat menu item, on the console it prints wheat toast. Choose the white menu item, console says white toast. You can set mnemonics and/or accelerators. So let's do that. We'll use W for wheat. Let's use I for white. And let's give the menu a T mnemonic. Some look and feels will honor these mnemonics by placing underscores that the user can see. But some look and feels will just ignore them and not do anything. However, pretty much every look and feel honors accelerators. We need to pass in a keystroke object. The easiest way to do that is to call the static method getKeystroke in the keystroke class. Say keystroke, getKeystroke. And I need to specify two things. I need to specify the character and the modifiers that go with that character. So if I want Control W, I'll specify the character W and the control key. However, if someone's going to run this program on a Mac, they'd probably expect Command W instead of Control W. And Swing provides a convenient way so you can set it to Control on Windows or Unix and Command on Mac. So we'll do that here. We'll specify W as a character. We'll call toolkit.getDefaultToolkit.getMenuShortcutKeyMask. And this is usually what you'll want to do. Call this method so that Windows users get the accelerator they expect and Mac users get the accelerator they expect. We could specify it manually. Let's do that here. Let's say we want this one to be Shift-Control-T on all platforms. Specify the T, and then we specify the bitwise OR of integer constants, one for Shift and one for Control. So this is the Shift one, Shift down mask in the input event class, or Control down mask. So you can see our mnemonic is here on many look and feels. Something like Alt-T would invoke this menu. And there's our W mnemonic and our I mnemonic. And you see the Command W here because I happen to be running on a Macintosh. And Control-Shift-T here. I'm going to type Command W and wheat toast appears on the console. I'll type Shift-Control-T and white toast appears on the console. I can put a second menu on the menu bar. Let's add these three JMenuItems to a new JMenu. Then add the bread menu to the menu. Let me show you two final things. One is, if you want a visual separator, say between waffle and biscuit, there's a method in JMenu to do that. It's called addSeparator. And the other is that not only can JMenuItems be added to a JMenu, but another JMenu can be added to a JMenu. So for instance, I can make the toast menu be a nested menu on the bread menu. Here's our separator between waffle and biscuit, and here's the nested menu. That's our lesson on JMenu and JMenuItem. This lesson's on working with JMenuBar. One thing I'd like to point out is that JMenuBar is a J component, and you can treat it like a J component if you really want to. So instead of setting it to be the menu bar for the frame, which is the usual way it's done, you can just add it as if it were any other component to some panel. So for instance, I could add it to the main panel here. There's rarely a need to do this, but here's our menu. So let me put that back. Let me point out that Frame has a method called setMenuBar. And the one that we had been calling before is setJMenuBar. So you need to be careful. If you try to add a JMenuBar using the setMenuBar method, it won't work because it's the wrong type. The setMenuBar method accepts an argument of type java.awt.menubar. setJMenuBar takes a JMenuBar. The setJMenuBar method is defined by JFrame, but it's also defined by the other window classes in Swing. So JFrame, JDialog, JApplet, JInternalFrame all have this setJMenuBar method. The last topic I'd like to cover is the placement of the menu bar in the frame. So this menu bar is placed at the top of the frame. But on some platforms, in particular the Macintosh platform, the users might expect the menus to appear up here at the top of the screen. In fact, this Java application has some built-in menus. If we'd like our menus, the toast menu and the bread menu, to appear up here, it can be done by a system property. But it only works in the Mac look and feel. So let me unset my look and feel. I've been using the cross-platform metal look and feel for most of these examples, so I need to turn that off. So this is the Mac look and feel, which by default still places these in the JFrame. But if I want them to appear at the top, I need to set a system property, and I could do it the same place I defined look and feel, or I can do it the first thing in main. Call system set property. The key is apple.laugh, which stands for look and feel. Use screen menu bar. Capitalize exactly like that, and set it to true. This won't have any effect on any non-Mac platforms, or as you saw, even on the Mac if you're not using the Mac look and feel. So if you have a single frame application, you might as well set this, unless there's some particular reason that you want Mac users to see the menu inside the JFrame. But you have to be careful if your application uses multiple frames. Let me show you why. Let me pop up a second frame here. So when this frame, which has the JMenuBar set on it, is the active frame, then my menus appear. But when this one, which doesn't have a JMenuBar set, is active, then there are no menus. If it's appropriate for the menus to change depending on which frame is active, then that's fine. You just set a separate JMenuBar on each frame. But if you want a multi-frame application to have what appears to be an unchanging menu bar on macOS, then you have to play some tricks in creating identical menu bars and setting them on all your frames, which may or may not be worth the trouble to do that. That's our lesson on working with JMenuBar. This lesson's on using actions with both menu items and buttons. I have a simple program that pops up a label. Let's create some menu items and some buttons that manipulates the label. And we're going to structure the code around the action interface. Back in the button chapter, we had an example with actions, and this will be very similar. First thing I want to do is pull this label and make it a class member. And now I'm going to create some actions. We'll create red action as an inner class, and same for blue action. And for this example, 2 actions should be enough. We'll define the red action class right here. Extends abstract action. It's polite to define a serial version UID. Let's write the constructor, and in the constructor we'll set several values for the action. The action interface defines the action perform method to be the method that will be invoked when the action's invoked. And what we'll do is set the foreground color of the label to be red. Which properties do we want to set in the constructor? We definitely want to set a name. Name is a constant that is specified in the action interface. And name would be enough, but for fun, let's set some icons and accelerators. If you specify both the small icon and the large icon, the small icon will be used for menu items, and the large icon will be used for buttons. But you can also just set one of them, probably the small one, and it'll be used for both if the other one isn't set. And we'll set Control or Command R for the accelerator. And for blue action, I'll just copy this. So we've defined 2 actions that are independent of the GUI elements that will invoke them. Let's go back to Startup and create those elements. So I can add a button for red action and a button for blue action to my main panel. So by passing an instance of an action into the JButton constructor, the button will configure itself with the action's properties. Notice that I'm instantiating a JButton, passing it to the add method of the panel, but we're not saving a reference to that button because there's no reason to save a reference to that button. We'll do the same thing for the menu items. So let's create the menu that the menu items will appear in. We'll add 2 menu items to this menu. New JMenuItem. And again, we'll pass in the constructor. Now we'll put the color menu on a menu bar. And we'll set the menu bar on the frame. Set JMenuBar. So we have a button that turns the label red. We have a button that turns the label blue. We have a menu item that turns the label red. And a menu item that turns the label blue. The red menu item and the red button invoke the very same action because we passed in the same instance to the button and to the menu item. If we extend the action performed for the blue action to disable the red action, now when I click this blue button, it will turn the label blue and it will also disable the red action. The red button is disabled and also the red menu item is disabled. I hope you can see that the action interface provides a very convenient structure for defining actions for buttons or menu items, or especially if you have both buttons and menu items. That's our lesson on using actions with menu items and buttons. This lesson's on JCheckBox menu item and JRadioButton menu item. I've written a program that has a regular menu item, coffee. Let's add a checkbox menu item to this. We'll call it bacon. And let's add an action listener. And let's query the selected status of bacon. So bacon is selected. And we'll add bacon to the order menu. So here's our checkbox menu item. It's deselected initially. If I click on it, the console says bacon set to true, and there's a check in the box. And if I click it again, it's unchecked, and it says bacon set to false. Now let's add some radio button menu items. We'll do 3 of these. And we'll add these 3 to our menu. There they are, scrambled, over easy, and poached. But what you'll notice is that they are not automatically made mutually exclusive. So I can turn on scrambled and over easy and poached. If I click on one that's selected, it deselects. In fact, it behaves exactly the same as JCheckBox menu item, except for instead of having a square box, it has a round shaped icon. But it's easy to add the mutual exclusivity. Actually, the first thing I'm going to do is add a separator in the menu before these radio buttons. First, we create a button group. Then we add the buttons exclusive to this group. Now, if I choose poached, it'll be selected. Now, if I choose over easy, that will deselect poached. If you need to programmatically determine which of the JRadioButton menu items is selected, we can do that. We create a button, and when you click the button, we'll figure out which one is selected. Just query each of the JRadioButton menu items to see if they're selected. Scrambled is selected. Over easy is selected. Initially, none of them are selected. It says false, false, false. If I choose one, false, false, true. And if this meets your needs, great, but you might want a simpler way to do this. It's the same thing you would have to do with regular JRadio buttons. We can ask the egg group which one is selected. This returns the selected button model, and one thing we can do with that is get the action command. Now, if getSelection returns null, this will throw a null pointer exception. So we either need to put this inside an if clause, or make sure that there's never no selection. And one way we can do that is to set one of these JRadioButton menu items to be selected in the beginning. So I'll turn scrambled on here. And since my action listener is calling getActionCommand, I should set an action command for each one of these. Now scrambled is selected initially. If I click this button, it'll say scramble. If I change it to post, it'll say post. The last thing I'd like to show you is that actions can be used with JCheckBox menu item and JRadioButton menu items. So let me write an action. The name of this action will be loyalty. You can give it an icon. We'll set an accelerator of L. For the action perform method, let's print a different string depending on whether the JCheckBox menu item is selected or deselected. Now that I've written an action, let's create a JCheckBox menu item and add it to the menu. And while we're at it, let's add toggle button and a checkbox on the main panel for the same action. When I run this, there'll be a menu item and a toggle button and a checkbox, but it doesn't work. If I select this one isn't necessarily selected. And the reason is to use an action with a toggle type button or menu item, you need to define another value, selected key in the action. This takes a capital B Boolean object, false if you want the action to be deselected initially, and true if you want it to be selected. And if the action has selected key defined, then JCheckBoxes or JCheckBox menu items will toggle the state when they're flipped. And here in the action perform method, we can also query whether the action is selected or not. So we'll compare the value of selected key to the value of Boolean true. So now it'll work correctly. If I click this toggle button, the checkbox will change and the menu item will be checked. If I uncheck it here, it'll be unchecked here. One thing I should mention is that JCheckBox does not show an icon. That's because the icon slot is filled with either a checked or unchecked box. But if you look at the JCheckBox menu item, it has both the icon that we set and also the checkbox. Just something to be aware of. That's our lesson on JCheckBox menu item and JRadioButton menu item. This lesson's on JPopupMenu. I've written a program that puts up a regular menu in the menu bar. Here it is. Let's change this so instead of being in the menu bar, that it's a pop-up menu. First thing I'll do is get rid of the menu bar. And then I'm going to change the type of the menu from JMenu to JPopupMenu. Now most look and feels will ignore any title you give to the pop-up menu. It's theoretically possible that some look and feel out there will display it, but I think it's simplest to just delete it. And now we have our pop-up menu. You add menu items to a JPopupMenu the same way you add them to a regular JMenu. Now there are essentially two ways to make a JPopupMenu appear. The first, set component pop-up menu on some component. So let me put it on the greeting. Say greeting, which is our JLabel, call set component pop-up menu, and give it a reference to our JPopupMenu. Now if the user right-clicks on this label, the menu will appear. With pretty much every look and feel, it's a right-click that pops up the pop-up menu. But theoretically, there could be some look and feel out there that has some different mechanism. Notice if I right-click someplace else, nothing happens. That makes sense. Only if we right-click on the JLabel. But we could change that. Let's say main panel.set component pop-up menu. And while I'm here, let me add a button to the main panel. Now I can right-click anywhere and the menu appears, even on the label. But if I right-click on the button, nothing happens. This is usually what you would want. But if for some reason you wanted the pop-up menu to appear when you right-clicked on the button, and this applies to other components also, for instance, JTextArea, we can call button set inherits pop-up menu. Now if I right-click on the button, the pop-up menu appears. I should point out that if this button were not in the main panel, but were inside a nested panel, or say inside a JScrollPane, and you wanted right-clicking the button to pop up this menu, you would have to call set inherits pop-up menu true not only on the button, but also on that intermediate panel or scroll pane. Okay, that's how you use the right-click to pop up a menu. Let me show you the other way. Let's make pressing the button pop up the menu. So we'll put an action listener on the button, and here we'll pop up the menu. You do that by calling show on the pop-up menu. Now if you look, you can see here that there are 3 overloaded show methods. The one with 3 parameters is the one that pops up the pop-up menu. The other 2 don't have anything to do with menus. So there are 3 arguments here. The first one is some component. Let's specify the label. And then the next 2 are X and Y coordinates relative to that component. So if I do this, pressing the button will cause the pop-up menu to appear at the upper left-hand corner of the greeting. There it is. Or I could change this to main panel, 200, 200. Now it'll appear near the lower right corner of the main panel. The more typical thing to do is to specify the button that's causing the pop-up to appear. That's our lesson on JPopupMenu. This lesson's on JSlider. I've written an application with a button and a label, and when you click on the button, the label updates. Let's add a JSlider to this. Call it S0. We'll start off with a default JSlider where we don't pass any parameters to the constructor. Let me add that to a panel. Let me change the action listener to get the current value of the JSlider. We'll call S0.getValue. Here's our slider. The default JSlider is in the horizontal orientation, a minimum value of 0, maximum value of 100. But I like to make it explicit. First parameter to the constructor is orientation. Next one is the minimum value. Next one is the maximum value. These have to be integers. And then finally, the initial value for the slider. And while we're here, let's decorate the slider with some ticks. We'll call set major tick spacing, say every 10. Then we'll call set paint ticks true. There's a tick every 10. We can also decorate the JSlider with labels. A couple ways to do that. The easiest is to call set paint labels true. So long as a major tick spacing has been set, this will work. See, we have a tick every 10 and also a label every 10. You have to be a little careful because if this slider were narrower, the labels would be printed on top of each other. If you know your JSlider is going to be big enough, then it's not a problem. But we might want to do this instead. Let's set the major tick spacing to 25, so there'll only be labels at 0, 25, 50, 75, 100. And we'll set a minor tick spacing and say every 5. Okay, let's create a vertical JSlider. JSlider.vertical. Let's set the minimum to 0, the maximum to 10, initial value to 5. We'll set the major tick spacing to 2 and the minor tick spacing to 1 and tell it to paint the ticks and the labels. And add it to the pane. Here's our vertical JSlider. I said the easy way to have your JSlider display labels is to set the major tick spacing and call set paint labels true. Let me show you the more customizable way. We'll create a new JSlider. And so this one will start at 0, go to 8, initial value 3. We'll have a tick every 1. And now we'll create a hash table of labels to add to this JSlider. Hash table is in the Java util package. You need to come up here and import it. Usually if you're writing code, you would use a map, like hash map instead of hash table. But the JSlider API requires hash table. Hash table, it maps integers to some J component, usually JLabel. Then we'll add entries to this hash table. So for 0, we'll put a label that says mute. For 1, we'll put soft. And for 8, the maximum, we'll put loud. We could add other labels if we wanted, but for a volume slider, this might be adequate. We need to call s2.setLabelTable, pass in the hash table. And we need to call setPaintLabels true. Let's add s2 to the pane. Here it is, with our custom labels. Let's add a JSlider with a minimum of 0 and a maximum of 1. You might use this for opacity. New JSlider, vertical, minimum 0, maximum 1, start at 0. Here it is, but it's not very adequate. If I want to put this a third of the way up, it'll snap to the 2 integer values that are allowed. We'd like this to allow floating point values. JSlider doesn't support that, but we can fake it. So instead of from 0 to 1, let's have it go from 0 to 1,000. Let's set the major tick spacing to 250 and the minor to 50. And now, to give it the illusion of being floating point, we need to set custom labels. For 0, we'll give it 0.00. For 250, we'll put 0.25. For 500, we'll put 0.50. And so on for 750. And 1,000. And call setLabelTable. Now when we get the slider's value, we need to divide it by 1,000.0. So it looks like it goes from 0 to 1. And it's set to 421, but we divide it by 1,000 and get 0.421. There's one final feature I'd like to mention, and that is you can set any slider to be inverted. This will reverse the low and high values. So in this example, the 0 is on the top, and the 1 is on the bottom. That's our lesson on JSlider. This lesson's on JSpinner. I've written a program that pops up an empty panel. Let's put a JSpinner in there. And add our spinners for the panel. Here's the spinner. Its current value is 0. An up button raises it. The down button lowers it. But you can see that it's not wide enough to show -3 or 10. And for that reason, flow layout is not usually the best choice to lay out a JSpinner. Another layout manager that's not a good choice is grid layout. Let me show you. Let me add a couple other components. Grid layout will stretch the JSpinner to fill the entire cell, so it's way too tall. What about border layout? Border layout isn't a good choice if you use center, east, or west, because like grid layout, it will stretch it. But north and south are good choices. It stretches it horizontally, but uses its preferred size vertically. I'm going to want several JSpinners in this example, so let me create a panel with grid layout to put them in. Notice that the initial value is 0. There's 2 ways to specify a different value. One is to simply call setValue on the spinner. Spin0.setValue, give it any value I like. The other way is to create it when instantiating the JSpinner. In the constructor, if we specify a spinner number model, the first argument is the initial value. The second argument is the minimum value, let's say 0. The third argument is the maximum value, let's say 10. And the fourth and final argument is how much the value should be incremented or decremented when the user presses the up or down button, let's say 2. Spin 0 starts with value 4. Spin 1 starts with value 4, but now when I push the up button, it'll go up to 6, because I specified 2 as the increment. Once it hits 10, it won't go any further, because I specified 10 as the maximum, and 0 is the minimum. JSpinner will allow the user to type in values. There's 2,345, but if you try something illegal, like A, B, C, D, it won't accept it. When focus leaves, it'll revert back to the previous value. Similarly, if I try to exceed the maximum, it won't accept it. It will accept an odd number. If you wanted to prevent odd numbers, you could create a subclass of spinner number model that enforced that restriction. Spinner number model supports not only integers, but also floating point values. So for instance, we could start with 0.5, specify -10.0 as our maximum, and 10.0 as our maximum, and the increment value to be 0.1. There's actually 3 constructors. One that takes ints, and one that takes capital N numbers. The number constructor is not designed for fancy numeric classes like big integer or big decimal. You pretty much have to stay with float, double, long, integer, short, or byte. But the reason it's there is so you can specify null as a maximum and/or a minimum. Null, of course, is not a legal integer or double, but we can pass in null as a Java-lang number. Specifying null as a minimum or a maximum simply removes the bound. There are two other kinds of spinner models. Let's create one using spinner date model. This will create a spinner with the current date and time for its value. Often that's what you want. But if you'd like to specify a specific date or time, the spinner date model constructor doesn't have a way to do that. So let's say we have a specific date in mind. So let's set the year as 2015, the month is September, the day is the 8th, the hour is 11 p.m., and the minutes is 35. Now it would be nice if we could just say spin2, set value, and pass in the local date time. But in fact, at least in Java 8, that won't work. If we're using spinner date model, then the value passed to set value has to be a Java util date, so we need to convert it. This conversion from the newer local date time to the legacy Java util date is a little cumbersome. It goes like this. Date from, and we give our local date time, but we have to provide a time zone. But we can call a method to get the system's default time zone. So there it is, September 8th, 2015, 11:35 p.m. JSpinner is actually pretty sophisticated with dates. The arrows act on the field the cursor's in. So if I click up, it's going to go to 12:35 a.m. on the 9th. Or I can change AM, PM, I can change the day, and so on. If the user types in something weird, like September 33rd, it will be corrected, in this case, to October 3rd. You can also change the numeric format for spinner number model. For spinner date model, you call setEditor on the spinner, and you give it a new jspinner.dateEditor. You give a reference to the spinner, and now you can provide a date format as a string. Let's say I want to have the month name, the day, a comma, a 4-digit year, and I don't want the time to appear. And for the spinner number model, I can call spin1, setEditor, new jspinner.numberEditor, pass reference to the spinner, and numeric format as a string. So let's say I want negative numbers to be in parentheses. So now negative values are in parentheses, and our date format's changed. The third spinner model, spinner list model, accepts a list or an array of arbitrary values. So let's create a list. To create a JSpinner for this list, we just say new JSpinner, new spinner list model, and give it our list. There's no way to specify the initial value in the constructor, but we can simply set it afterward. For spin3, I used a list of strings, but you need not be limited to strings. Let's say I have an array of some other type. The type of this array is chronounit in the java.time.temporal package. Even though these values are not strings, they're displayed as strings. JSpinner is simply calling the toString method on the value to convert it to a string that can be displayed. That's our lesson on JSpinner. I've written a program that displays a slider and a spinner. Let's say we want to do something with their values when the user clicks the print button. We'll add an action listener to the button, and to get the slider values, we can call slide.getValue. And we can also call spin.getValue. This works, but there's an issue, and that is slide.getValue returns an int. So I can say int delta equals slide.getValue. But spin.getValue returns an object. So if I try subtracting the spin's value, it won't compile. Now since we passed integers to the spinner number model when constructing JSpinner, getValue will return a capital I integer object. So we could cast it to a capital I integer and have it unboxed to an int. But rather than casting it here, I usually prefer to write a utility function. I could cast an integer here, but I'll use number, the superclass of integer. Let me add a javax.swing.timer to our button listener. 2000 milliseconds, 2-second delay, and then we'll print out the spinner's value and call our utility function. We don't want it to repeat, just do it once and start the timer. Now when I click on this button, it will print that the value of spin is 13, wait 2 seconds, and then say that it's still 13. But I can change it in the meantime. It says 13, now it's 17. This 2-second delay is artificial, of course, but I did it to show you what can happen with the JSpinner when some asynchronous event not tied to the GUI wants its value. I'm going to press this button, and I'm going to type a new value into the spinner. I'm not going to use the up and down buttons. And if you look down here, it says now spin is 17. Didn't catch the 5. And that's because the user did not hit the return key or did not move focus outside of the spinner. This behavior might be what you want. In some applications, that's appropriate. But often users will find this counterintuitive. And the way to fix it is to call commitEdit at the beginning of our utility function. Spin.commitEdit. This will attempt to commit whatever the user might have typed into the spinner's field, just as if the user had left focus or hit return on the keyboard. Unfortunately, commitEdit throws a checked exception, so we have to catch it. So I'm going to push print, I'm going to type in 22, and even though I didn't press return or lose focus, it printed the 22 down here. This works if the user types a valid number in. Let me show you what happens if the user does something else. So I'm going to push the print button, and I'm going to type in letters. We got a parse exception. Even though it's not likely that the user will do this, you probably don't want your application to print exceptions to the console. We should change the exception handler to do something. And what's best depends on the application. You could just set in some constant value. But one thing you might want to do is have the spinner revert back to its previous valid value. And there's a few different ways to do that, all of which are somewhat cumbersome. But I'll show you what I think might be the least cumbersome. Call spin.getEditor, and then cast this to a change listener. Change listener is in the javax.swing.event package. Then call stateChanged and pass in a newly constructed change event, which is in the same package. Then pass the spinner to the change event. So I'll press print, I'll type AA, and then after 2 seconds, the AA gets changed to 10 because of what we did in the exception handler. Let's say I want to be notified immediately if the user changes the value of the spinner. We can do that by adding a change listener to the spinner. Let's force the slider to adopt whatever value the user sets in the spinner. So we'll call slide.setValue, and then we'll pass here spin.getValue. And again, we have to cast this to an integer or call our utility function. Usually, it's polite to call commitEdit almost any time calling getValue on a spinner. But because this code is inside a change listener, it will only be called when the spinner itself is notifying listeners of a change. It's not really necessary here. So every time the user clicks a button on the spinner, the event handler gets called. If we'd like to be notified whenever the user changes the value of the slider, it's very similar. We'll add a change listener to the slider. And we'll call slide.getValue and pass that to spin.setValue. Now whenever the user changes the value of the slider, the spinner will change. Notice that if I continuously drag the thumb, that several events are fired. That works well in this simple example. But if the event handler did something time-consuming, like access a database or something like that, then we probably don't want 10 events to be fired. If I move this over 10, then it's not hard to do that. What we need to do is call JSlider's getValueIsAdjusting method. So if it's not the case that the value is adjusting, then set the spinner's value. So if the user drags the thumb to the right, our change listener is being called several times. But getValueIsAdjusting is returning true. Not until the user lets go of the button that getValueIsAdjusting returns false, and we actually change the spinner's value. Let me change it back to the other way. I should point one thing out before we go, and that is, if the user changes the spinner, this change listener will be called, and this will set a new value into our slider. When that happens, this change listener will be called, and this is going to set a value into the spinner. So we should consider whether there will be a feedback loop, where this listener calls this listener, calls this listener, calls this listener. That would be a mistake to create an application that did that. But in this particular case, we were okay. Because if you call setValue and pass in the value that's already the current value, that component will not fire an event. So we won't have a feedback loop in this case. That's our lesson on reacting to events. This lesson is on the JList class. I've written a program that places a button in a flow layout panel. To create a JList, I need either an array of objects to place in the list, or a Java util vector of objects to place in the list. If you're not familiar with vector, it's very similar to ArrayList. It just so happens that JList was added to the JDK before ArrayList was, so JList uses vector instead. So let's create a vector of strings. Let's populate it with a few values. And now let's create a JList and pass in our vector. We need to add the JList to the panel. Now, it's syntactically legal to pass it in plain like this, but it's almost always a mistake. The JList should almost always be wrapped in a JScrollPane before it's added to a panel. And we can do that in line here. Just call new scrollPane and pass in the JList. There's our button. There's our JList. Notice that none of the objects in the JList are selected. That's the default behavior, but we can change that. I can either call setSelectedValue or setSelectedIndex. We set the selected index. Index 1 corresponds to vanilla. And while I'm here, let me add an action listener to this button. JList.getSelectedValues returns an array, since arrays don't have a good toString method. Instead, I'll call getSelectedValuesList, which returns the selected values as a Java util list. GetSelectedIndices returns an int array, and there's no method that returns a list. So we need to wrap this in something to make the print line look nice. Arrays.toString. Notice vanilla is selected when the frame pops up. If I click this button, it will print selected values are vanilla, selected indices are 1. If I select all three of these, it says selected values are chocolate, vanilla, strawberry, selected indices are 0, 1, 2. These will always come out in increasing order by index, no matter in what order the user selects them. If I deselect everything by command clicking or control clicking, then it says selected values are empty, selected indices are empty. Notice that even though we only have 3 objects in this list, there's room for a lot more, which makes this look not very attractive. Let me explain how this works. First, let me change this so that we have more than 3 items. Let me create an array called months with 12 values. I'm doing this not only to get more items in my list, but also to make it clear that the objects in a JList do not need to be strings. They can be any object type. They'll be displayed as strings using the toString method. Here's our list with 12 items. 8 of them are visible. The scroll bar appears because it's necessary to show the 12 items. I can scroll down to see the rest. The reason it chose 8 items by default is because JList has a property called visible row count, and the default value is 8. And what this property does is tell the JScrollPane that will be wrapped around the JList how big its preferred size should be. So if I set it to 4, the JScrollPane will be set to a size big enough to hold the first 4 items. So if you wanted all 12 to appear, you could say set visible row count 12. And if the frame has room for it, they'll all show up. Notice that because this frame is using flow layout, that if I resize the frame, it doesn't change the size of the JList. But if I lay the frame out with border layout instead, then that'll no longer be the case. I'll put the JList in the center of the border layout. And now the value of visible row count doesn't matter, so I'll comment it out. Although leaving it in would have no effect. Now if I change the size of the frame, it'll change the size of the JList. There are other properties in JList we could set. For instance, we could call JList.setFont, and that would change the font. We could call setForeground, which would change the color of the text, or setBackground, which would change the color behind the text. These are properties available to most Swing components. But JList defines a couple new ones. One is set selection foreground. So now selected items will show up in red. Or I can call set selection background. That changes the background color of selected items. Notice I can set any number of discontinuous regions, but it's easy to disallow that. Just call set selection mode. And there's three choices. List, each defined by a constant in the list selection model class. Multiple interval selection is the one you just saw, where any combination of selected and unselected items is allowed. Single interval selection allows multiple items to be selected, but they must be contiguous. So I can click March, shift-click June, and those are selected. But if I control-click or command-click August, it adds it, but it deselects the others first. That's single interval selection. If you want at most one item to be selected, then you can set the selection model to single selection. If we're going to do that, we might as well change our action listener. Since there can only be one selected value, we can call getSelectedValue or getSelectedIndex. Selected value is April, selected index is 3. If multiple selection were allowed, the methods getSelectedValue and getSelectedIndex would simply return the first selected index, ignoring the rest. If there's nothing selected, then these two methods return null for selected value, -1 for selected index. That's our lesson on the JList class. This lesson's on using JList with columns. I've written a program that has a JList with the US state names. By default, JList displays them in a single column. But JList has functionality, which I think is underutilized, for laying out list items in columns. It can be enabled by calling JList.setLayoutOrientation. There are two choices beyond the standard vertical mode. Let me show you a horizontal wrap first. I need to do something else to make this work properly. Let me show you what happens if I forget to do that. States are laid out in multiple columns, but it's not utilizing the space available to the JList very well. By default, it will show 1, 2, 3, 4, 5, 6, 7, 8 columns. And that's because the visible row count property has a default value of 8, which we need to disable. What we need to do is set that to 0. And now it will lay out as many columns as fit in the width allowed to it. If I reduce the width enough, the scroll bar will appear so that all the values can be selected. In the horizontal wrap mode, it lays out the items horizontally. So the first one, second, third, fourth, fifth. I think it's usually cleaner to lay the items down in a column. That's called vertical wrap. And just with horizontal wrap, it's very important to call set visible row count 0. Now the items are laid out to the first column, and then when room runs out, in the second column. Changing the height of the frame will change the number of columns, because each column will fill the allowed space. If I make the height too small, it will create rows past the edge of the frame, and the scroll bar will appear to allow me to select them. If you look at District of Columbia, which happens to be the longest item, there's not much space between the end of that and the beginning of the next column. There's some ways to adjust that. These techniques work for multi-column layout orientations and also the default single-column layout orientations. One thing we can do is call JList.setFixedCellWidth. Give it some number of pixels. Let's say 150. 150 was enough to give more space. If I instead set it to something smaller, let's say 90 pixels, this allows it to fit in more columns in a smaller space. But some items, like District of Columbia, New Hampshire, Massachusetts, North Carolina, South Carolina, are displayed with ellipses. Of course, the underlying value is still South Carolina. The display is truncated. If we want there to be more horizontal space between items, we can call setFixedCellHeight. Let's say 22 pixels. And this can be done in conjunction with FixedCellWidth or on its own. Finally, there's a method called setPrototypeCellValue. This can be used in place of FixedCellWidth or FixedCellHeight. You pass in a value, in this case a string, since this is a JList of strings. That's the size you want. So if I say Puerto Rico, and Puerto Rico is exactly the right size, and anything larger will be truncated. One trick you can use for strings is set this to your longest string and add some spaces on the end. Let's say 2 spaces. It gives a nice amount of space between the longest item and the next column. These techniques of setting a fixed cell width, fixed cell height, or a prototype cell value are important for 2 reasons. One is just aesthetics, making the spacing look better. But the other is efficiency. This list only has 54 items in it, so efficiency isn't a big deal. But a JList could have thousands of items in it. If you don't set a fixed cell width and fixed cell height, or a prototype cell value, it needs to examine each of those items looking for the largest one. And that can slow down the display of a JList if there are a lot of items in that JList. So if you have a lot of items, set a fixed cell width and height, or set a prototype cell value. That's our lesson on JList with columns. This lesson's on JList Events. This program displays a JList, and when the user clicks this button, it reports which values are selected in the JList. But what if we want to be notified immediately when the user changes the selection? With JSlider or JSpinner, we could add a change listener. But that's not how it works with JList. For JList, first we need to obtain the selection model of the JList. So we'll call JList.getSelectionModel. Then on the selection model, we'll call addListSelectionListener. Typically, in a list selection listener, we'll want to ask the event if the value is adjusting. So we'll say if it's not the case that the value is adjusting, then we'll do something. Now this print line will be executed whenever the user completes changing the selection. So it reported that change. If I deselect this, it'll report that change. If I hold down the Shift key and push the down arrow, on every down arrow press, I'll see a selection change message. That doesn't count as the value adjusting. Okay, that's selection changes. Something else you might want to do with a JList is detect when the user double clicks or triple clicks on an item. So if I double click on Kentucky, right now it reports the selection change, but it doesn't do anything special for the double click. And we might want to pop up some description of Kentucky, for instance. We can implement this by adding a mouse listener to the JList. Unfortunately, we can't use lambda notation because mouse listener is not a functional interface. Probably the easiest way to do this is to create an anonymous subclass of mouse adapter. So we'll say new mouse adapter, and then in braces, we'll provide the mouse clicked method, because that's the relevant method in mouse listener to detect mouse clicks. If we're only interested in double clicks, we want to filter out the single clicks and the triple clicks, and so on. So we can call e.getClickCount. And only do something if the click count is equal to 2. That catches our double clicks. It takes a little bit of effort to determine which item was double clicked on. The first step is to ask the JList which index corresponds to the location that was clicked on. So we'll call JList location to index, and then we'll give it the location of the click by calling e.getPoint. Now that we have the index, we can convert that to the item string. The way you do that is called JList.getModel. Then ask the model which element is at that index. So if I double click on Minnesota, it reports the selection change from Minnesota from our list selection listener we had already added, and it also reports the double click. I should point out that that location to index method that we called in the mouse listener is fairly lenient. If I double click on this space right here where there's no list item, it reports double click on Wyoming. Or if I double click outside to the right of the West Virginia item, it will report West Virginia. Or under New Mexico, print New Mexico. Sometimes that's what you want. But if you want to be sure that the double click is actually on the item, we can do that. What we can do is call JList's getCellBounds method and pass in the index, and then pass in the click index again, because this method accepts a range of indices. This method returns a rectangle containing the boundaries of that cell in the JList. We can ask that rectangle whether it contains the click point. So we can use an if statement to only act if the click was in bounds. So if I double click on Maryland, it reports the double click. Double click underneath Maryland, I don't see anything. Double click under New Mexico, it reports the selection change, but not the double click. But if I double click on New Mexico, it reports the double click. I should mention that it's theoretically possible for the location to index method to return -1. That would cause problems with the next 2 lines of code in this mouse adapter. But that can only happen when the list contains no items. So long as there's at least one item in the list, the location to index method will return the closest item to the mouse click. That's our lesson on JList Events. This lesson is on JComboBox. I've written a program that displays a button. Let's add a JComboBox to this program. First, we'll need either an array or a java.util.vector containing the items to be shown in the combo box. Let me add some strings to this vector. Now we can create a JComboBox with these items. Flavor combo, new JComboBox, and pass in the vector. We'll add it to the frame. And here it is. It shows the selected item and a button that can be used to show the other possible items. By default, the first item will be the one initially selected. If you want to change that, you can either call setSelectedItem, like this, or setSelectedIndex. Let me create another combo box, this time from an array. New JComboBox, and pass in the array. Let's add a JLabel here. So vanilla is the initially selected item for that combo box. This combo box appears, but it's pretty narrow. If you think it would look better aesthetically to be wider, there's a couple ways we could do that. We could set a preferred size to the combo box. Or, just as with JList, we can set a prototype display value. If we pass in a 3-digit number, like 100, then the box will be created wide enough to contain that 3-digit number. Let me add an action listener to this button. Here's our wider combo box. If I click this button, it will say Order, 2 scoops of strawberry. Both of these combo boxes are non-editable. That means they provide a fixed list of choices. But let me demonstrate an editable combo box. All we do is call flavor combo, set editable. Most look and feels will display an editable combo box slightly differently from a non-editable one. Notice that has a white background now. With an editable combo box, we can just type in any value we want. If you'd like to be notified as soon as a user changes the selection of a combo box, we can add an action listener to that combo box. This action listener will be invoked whenever the user changes the selection on a combo box, either by choosing one of the fixed values, or if the combo box is editable, by typing in a new value, and either typing return or moving focus away from the JComboBox. I should point out that the return type of getSelectedItem is object. You might expect it to be integer, since it's a JComboBox of integer. So if we made scoops combo editable, the user could type in any string, and the getSelectedItem method would return that string as a string. But if the user chooses 1, 2, or 3, that'll be returned as an integer. We set this to 2, it says scoop selected 2, or 3. We're notified even if we select the item that's already selected. Let's say I want to order 3 scoops of peach. Now order strawberry. Now I want peach again. It's not here. We could type it in again, but sometimes it would be appropriate to add the user typed value and make it one of the fixed values in the combo box. We can call flavor combo getSelectedIndex. This will return the index of the selected item. So for chocolate, it would return 0. Vanilla, it would return 1. For strawberry, it would return 2. If the user types in vanilla instead of selecting it from the list, it will also return 1. But if the user types in something new, then getSelectedIndex will return -1. So that's what we want to detect. So we'll check if flavor combo getSelectedIndex is less than 0. It's tempting to try to add the new value to this vector. Remember, we have to cast getSelectedItem to the correct type. This is a dangerous thing to do. because when we pass possible flavors into the constructor for the combo box, it keeps a reference to it. But the JComboBox won't notice if we add a new thing to this vector. In fact, it could become confused that the vector is not as it expects. So in general, you shouldn't do this. Perhaps the cleanest way to achieve this goal is to create a custom model for the combo box that can be given a new value and fire events notifying the combo box of the new item. And that's certainly possible, but it would involve writing a new class that implements the combo box model interface. And there's another way to do this that takes only a couple of lines. What we can do is call setModel on the combo box and pass in a new default combo box model built around our vector. The setModel call will replace the previous combo box model, which was also built around that same vector. A side effect of calling setModel is that it will reset the selection to the first item in the vector. It would be weird for the user to type in a new flavor, hit return, and have the combo box immediately switch back to chocolate. But we can manually set it back to the new item. Set selected item or set selected index. Since we added the new flavor to the end of the vector, we'll just give it the index of the last item in the vector. Our list says chocolate, vanilla, and strawberry. But I can type in another flavor and either hit return or change focus to some other component, like this other combo box. And our action listener will have added black cherry to the list. Let me try it again. Coffee, hit return. Coffee's on our list. That's our lesson on JComboBox. This lesson's on custom list renderers. I've written a program that shows a combo box and a JList. If we want to modify how these list items are rendered on the screen, we can create a custom renderer and set it into the combo or the JList. I've already written the skeleton of a custom renderer as an inner class called Label Renderer. And the way Default List Cell Renderer works is that Default List Cell Renderer itself is a subclass of JLabel. So a Default List Cell Renderer is a JLabel, but it provides one extra method. And that's the method that the JList or the JComboBox will call to obtain the renderer it uses for printing its items. This method takes 5 parameters. It takes a reference to the JList that it's rendering for. This would be a subcomponent of JComboBox that usually is not apparent. The value of the cell it's going to render, the index of the cell it's going to render, whether the cell it's rendering is selected, and whether the cell it's rendering has focus. If we call super getListCellRenderer component, it will set a bunch of properties on this label. It'll set the border, the icon, usually to null unless the value is an icon, the text, the font, foreground color, the background color, and the enabled status. If we wanted to change any of those, we could, or we could set some other property of the label, for instance, the horizontal alignment. Let's say for some reason we wanted to change the alignment only for the selected cells. So we could ask, if is selected, you can call set horizontal alignment and set it to right. This is actually incorrect. To be correct, we have to do something else. But I want to show you what happens when we try the renderer this way. So we need to instantiate an instance of this renderer. New label renderer. Now we need to set this as the combo box's renderer by calling the setRenderer method. And we can set the same renderer into the JList, this time by calling a method called setCellRenderer. Now both of these components will use the custom renderer we wrote. So if I select one of these items, the alignment should shift to the right. And it works. But here's the problem. If I scroll down to expose more elements, you'll see those are shifted to the right also. If I scroll back up, these first 3 are shifted right. And if I click over here, these are all shifted. The problem is that this label renderer instance is used over and over. It configures it for the first item it needs to paint, it paints it. And it configures it for the second item it needs to configure, and it paints that, and so on. It's used as a rubber stamp to paint each of the combo boxes or the JList elements one at a time. So once we set the horizontal alignment of this label to be right, it'll stay that way for every other item that gets rendered. We need to set the horizontal alignment to something that's appropriate no matter what. So we can say else set horizontal alignment left. Even though left is the default alignment for a label, we need to set it right for some things, and then for other things we need to set left again. So the rule is, for these renderer components, You need to set all the relevant properties every time that this method is called. And that's what super.getListCellRenderer component does. It always sets the border. It always sets the icon. Sometimes the null, but it's always set. It always sets the text. It always sets the font. It always sets the foreground and background colors. Before I run this, I want to mention one thing. And that is, if you look at list renderers that have been written by other people, sometimes they use this style of calling super, changing values, and then returning this. But sometimes you'll see this written in another style, like this. JLabel, we have to cast the return type of super getListCellRenderer component to JLabel. And now that we have this component called lab, we set the properties on lab, and then we return lab. Because super.cellRenderer component returns this, it works out the same either way. It just looks different in the code. And I wouldn't say one style is superior to the other. If you write it this way, you're relying on the fact that super.getListCellRenderer component returns a JLabel. And if you write it the other way, you're relying on the fact that super.getListCellRenderer component returns this. There's no good way to extend default listCellRenderer without making one of these assumptions. Let's try this out. So now if I select 6, 8, 10, and 12, they'll shift to the right. They shift 18 and unselect 8, and they'll shift back to the left. It works. I should have erased this. It's no longer incorrect. While we're here, we could do something else. For instance, let's set an icon on this label. This value is going to be an integer, but its type is object, so I'll need to cast it if I want to use that value to set my icon. So I'll do that in a careful way. If value is instance of number, we can multiply it by 12 and make sure it's between 0 and 255 and set a ball icon on this label. Diameter 15, 0 for red, the RGB value for green, and 255 minus the RGB value for blue. If I wanted to be real pedantic, I could say else lab.setIcon null. But I don't need this in this case. And that's because super.getListCellRenderer will have set it to null. Note that we're calling new ball icon and new color on every call to getListCellRenderer component. Ideally, this method, getListCellRenderer component, should execute very quickly. So if a list has many items, it can just zip through them without wasting a lot of cycles. So something that might be worth doing is we could restructure this code so that it didn't instantiate icons and colors in this call. For instance, we could create a constructor for a label renderer that creates a single ball icon and put a color setter into that ball icon, and then down here, set the color into that icon. If this renderer were going to be used a lot, it might be worth going to that effort. If you want your renderer to be based on a JLabel, which is usually the case, then default list cell renderer is definitely the class to extend. But it's possible to use other components for a renderer. And so I've written a skeleton of a renderer that uses a slider. This is an example. So in this case, instead of extending a class, I'm implementing this interface. I've chosen to use the integer type here, which means that the type of value is an integer, and the type of this JList is something that extends an integer. So the idea is, in the constructor of this renderer, we instantiate our slider, and we configure it. For instance, I could set the minor tick spacing, 5, and set pink ticks to true. And then in the getListCellRenderer component, we configure the slider and return it. I can set the value of the slider to the value of the list item. I need to do more than this to make this a decent renderer. Well, let's take a look at what we have so far. So for the JList, I'll set in our new slider renderer. Pass in 20 as the max value for the slider. Let's take a look. There they are. They're a little bigger than I would like. So let me call JList set fixed cell width, say 120 pixels. And now that I'm using this renderer, there's really no point in calling set prototype cell value. Although if I left it there, it would be harmless. Let me point out a couple things. The first is that even though these look like JSliders, they're not. I can't drag the thumbs. These are not live components. They were just used transiently as rubber stamps to paint the value of the cell, and that's it. And the other is that if I click on these, they're being selected, but I neglected to change the background of my component. So it's impossible to tell which items are selected and which aren't. So we need to fix that. So we call slider.setBackground, and we want to set one color if the cell is selected and a different color if the cell is not. So if it's selected, we'll use the color that's set as the selection background for the JList. And otherwise, we'll use the color that's set as the normal background in the JList. I should use something similar for cell has focus. Typically, focus is indicated by a border around the cell. So let me create two borders, one for when the cell has focus and one when it doesn't. For the normal border, let's have an empty border, 1 pixel wide. And for the focused border, we'll have a colored border 1 pixel wide. The idea is that these two borders should be the exact same size, so that when a cell becomes selected, the component doesn't appear to shift. Call set border. And if the cell has focus, we'll set the focus border. Otherwise, we'll set the normal border. Now when I select one, you can tell that it's selected. That's our lesson on custom list renderers. I've written a program that places a J button in a J panel under flow layout. Let's add a JText field to this panel. New JText field, add it to our panel. This little thing is our text field. If we were using a layout manager that stretched the field horizontally, like the north and south areas of a border layout, then it would stretch our text field and it would look fine. But under flow layout, we have to make sure that it gets a more reasonable size. One way to do that is to specify an initial value for the text field. If I do this, the field will be just big enough to hold that text. Or I can specify a width in columns. This leaves more room for the user to type a longer string. Or I can not specify an initial value and just specify the number of columns. The text field supports look and feel appropriate keyboard behavior, including copy, cut, paste. So I'll cut, paste, paste, paste. I can use keyboard navigation with the arrow keys. Or if I hold down the Shift key and use the arrow keys, it creates or extends a selection. If we want to obtain the text that was typed into the text field, then we simply call the getText method on the text field. Let me do that in an action listener for this button. Text field, getText. And it says sample. This works not just with JTextField, but with any of the text components that Swing provides. Something else we can do is add an action listener on the field itself, which will be triggered when the user hits the return key. The syntax is exactly the same as with the button. Add action listener, then provide the handler. Text field .getText. The single line Swing text components like JTextField support this. The multi-lines do not. So I'm going to hit return on the keyboard, and here it says action from field sample. One last thing I'd like to talk about is borders on text fields. Some look and feels even provide focus effects with a different looking border when the field has focus and when the field doesn't. The border you see here is a regular border set on the field. So if we try to set our own border, let's say an empty border with 20 pixels, this will replace the border we saw earlier. So the text field works, but it looks a little weird. Or if I create a titled border, it still works, and there may be times when you want this effect, but it's not a look that you would usually want. If you really want to put a border around the JText field, it's probably best to put it in the center of a panel with border layout, and then put the border on the panel. So let's see how that would look. New border layout. P.add a new text field. We'll add panel P to the main panel. Now the title border is there, but also the text field's border. That's our lesson on JTextField. This lesson is on JPasswordField. JPasswordField is very similar to JTextField, with a few changes for better security. I've written a program that instantiates a JTextField and places it in the north region of a border layout. Border layout stretches it left and right with the frame. Let's extend this to have an additional field for the password and have labels to the left of the fields. First, I'll create the password field, new JPassword field. I think the easiest way to lay these out is to create separate panels for the fields and for the labels, and then to combine them in another panel. So we'll do the labels panel first. New JPanel with a grid layout with one column. Same for the fields panel. The form panel, we'll use border layout. And we'll add the labels panel to the west part of form panel and fields panel to the center. Now we populate the labels panel and fields panel. New JLabel, login name, this panel.add. Then again for the password field. Now we need to add the form panel to the main panel. North is the right place for it. Let me show you what happens if I instead use center. If I place the form panel in the center, then it will be stretched vertically, which is kind of ugly. If I put it back in north, then the layout's a little more reasonable. Notice that these labels are left aligned. If you think they'd look better right aligned, which is a personal preference, we can do that. You just specify an alignment in the constructor to JLabel. Let me add action listeners for the button and for the fields. Since I want them to do the same thing, I'll create a method called login. So for the button, we'll call login. The username field we'll call login. And for the password field, we'll call login. I can obtain the contents of the name field by calling nameField.getText. Now, this is not recommended, but I can do the same thing for the password field. The getText method is deprecated inside JPasswordField, which is why the editor is showing it strike through. I'll fix that in a moment. Now, a real program should never print out the password. We'll do so just for demonstration. I'll type in a username. I'll type in a password. Notice that the look and feel obscures the password with these dots. It also restricts copying and pasting from the field. When I click the button, it says login attempt with name quincunx and password ABC. The Java docs for JPasswordField recommend that instead of calling getText, we call getPassword, which returns an array of characters. And it also recommends that when you're done using the password, that you zero out the contents of the array. We can call arrays, which is in the Java util package, .fill, the password array, character 0. Now in your program, you should take whatever steps you need to make sure the security meets any requirements. But the reason that they recommend calling getPassword and storing into a char array is because strings are immutable and can't be cleared and may persist in the JVM for a while. Let's say I want the user to type the password twice for verification. I'll create another JPassword field, add them to our labels panel and fields panel. In the login method, I can call getPassword on the verify field. I can use arrays.equals to see if those two passwords are the same. Pass in the first char array, pass in the second char array. And now that I know whether they are the same or not, I can zero out the verify. If the passwords don't match, we should probably provide some textual feedback in the GUI. But for this example, I won't do that. And if I want, I can blank out the two password fields. Set text, empty string, verify field, set text. I'll type one password here, and I'll intentionally mistype a password here. Passwords do not match. And the fields got cleared. I'll type the same password. Since the passwords do match, it says login attempt with name quincunx. I probably should have added an action listener to the verify field. That's our lesson on JPasswordField. This lesson's on DocumentListener and DocumentFilter. I've written a program with 2 JText fields and 1 JLabel, all initially with no text. Now usually we aren't concerned with the contents of a text field until the user's done typing and either hits the return key on the keyboard or moves the mouse and pushes a button or something like that. But what if we were trying to implement something like a predictive text system, and we were interested in being notified whenever the user deletes or adds characters to the field? With some components like JSpinner, we could add a change listener to the component. That doesn't work with Swing's text components. For text components, we need to add a document listener. Let me first import some packages we're going to need in this lesson. javax.swing.event.star contains document listener and also document event. And later on, we're going to need javax.swing.text.star. The first thing we need to do is obtain the text component's document by calling getDocument. The document is what holds the actual text of the text component. Other aspects of text components, like which characters are selected or where the caret location is, are held elsewhere. The document just holds the text. And by adding a document listener, we'll be notified whenever the component's text changes, but not when the caret position changes or the selection changes. So we'll call add document listener on the document. The document listener interface is not a functional interface, so I can't write a lambda expression here. We have to actually instantiate the document listener interface. So we'll say new document listener, open brace, and now we'll write the methods. There are three. There's insert update, called whenever characters are inserted into the document. There's remove update, which will be called whenever characters are removed from the document. And there's changed update. This will be called when text is neither inserted or removed, but simply changed. In some circumstances, we might be interested in the details of the insertions or removals. We could call methods on document events to figure out what locations have been changed. But for this example, I'll just call a method called React in all three of these listener methods. We'll take the field's text and set it onto the label. So we'll call statuslabel.setText plainField.getText. So now whenever the user makes any change to the content of this field, the label will change. And you can see that every letter typed is reflected in the label. I'll delete these characters. That's document listener. Now let's say we wanted to restrict the contents of a field in some way. For example, we could enforce a maximum length of the contents. Or we could prevent any lowercase characters from being typed. Or we could only permit numeric characters to be typed. This is what DocumentFilter is for. What I'd like to be able to call is numericField.getDocument.setDocumentFilter, and then pass in the filter. But unfortunately, I can't do this directly. The setDocumentFilter method is not defined in the document interface. Instead, it's defined in the AbstractDocument class. Now, in fact, all Swing text components will have a document that's a subclass of AbstractDocument. The only exception would be if you've explicitly set some different kind of document onto your components. So what we can do is we can cast the result of getDocument to AbstractDocument. And then we can call setDocumentFilter on the AbstractDocument. But now we can create our document filter. Document filter is not an interface like document listener is, but it's a class. It's not even an abstract class. So we can choose which of its methods we'd like to override. There's insert string, and the arguments are a filter bypass, the offset where the text should be inserted, and a set of attributes which could be null, describing the style of the text to be inserted. For JTextField, the style information is not really relevant, but document listeners and document filters can be added to any Swing component, not just JTextField. In some of the more complicated ones, these text attributes could be relevant. There's the remove method, which takes a filter bypass, the offset where the removal should occur, and the length of that removal. And finally, there's replace, which takes a filter bypass, the offset where the replacement will happen, the number of characters that are being replaced, and the text it's being replaced with. And again, a set of attributes, which could be null. The idea of the replace method is that it combines an insert string and a remove into one atomic operation. So if our constraint on a text field were a fixed length, let's say the length has to be 8, any removal or any insertion we would reject, but we might accept a replacement so long as the length of characters being replaced matched the length of the replacement string. All three of these methods are declared to throw bad location exception. This filter bypass is an object which provides methods to actually change the field. So when the user types a letter on the keyboard and the document filter is set onto the document, then this insert string method will be called to see if the insertion is allowed or not. If we want to allow it, we call bypass.insertString and pass it the offset, the text, and the attributes. And then the document will actually be changed, and the text field will show the change. By the way, if you're looking at other people's code, sometimes they'll write, instead of bypass.insertString, they'll call super.insertString, bypass offset text attributes. This does exactly the same thing, because if you look at the implementation of insert string in DocumentFilter, it just does this. So do one or the other. And the same for remove. If we want to allow the removal, we call bypass.remove offset length. And if we want to allow the replacement, we call bypass.replace offset length text attributes. So what we've written so far just allows every edit to occur, but we can modify the behavior. For example, if we wanted to allow the user to add as many characters as he or she wanted, but not to be able to remove any, we just comment this out. So when the remove method gets called, we don't allow the removal. And in the replace method, we can only allow it if the length is 0. So let me undo that. If we want to prevent any lowercase characters from being entered into the field, instead having them be converted to uppercase characters, we can do that. In the insert string method, we can just call text.toUppercase when passing the argument into the filter bypass. And for remove, that wouldn't have any effect on lowercase characters getting into the field, so we could just comment this out. Or leave it the way it was, since it was allowing all removals. And then replace, we could also call text.toUppercase. But I hesitate to do this, and that's because the documentation for the replace method mentions that text could be null. In practice, I don't think that would ever happen. But if it were, this would cause a null pointer exception, and we don't want that. And so instead, we could do something like this. If text is not equal to null, then text equals text.toUppercase. So we're changing text to be a different string, and then passing that new string to the filter bypass. And we could do the same thing, just to be extra careful, up here in the insert string method. So let's try that. I'm typing lowercase letters here, but you can't tell. But what I can do is I can take some lowercase letters into here, copy paste them into the other field. So I'm about to paste them in, and they appear in all uppercase because of the document filter we've added. If we wanted this field to only accept numeric digits, change the filter to do that. Instead of calling text equals text.toUppercase, we can take the text, we can split it with the runs of non-numeric characters as the separator. That's what this \g plus regular expression means. And then we can take those strings and we can join those strings together directly with no intermediate delimiter. This will assign to text a string that contains only the digits from the original text. Let me copy that down here to the replace method. I can type numbers like 1, 2, 3. I'm typing A, B, C, D. They're not appearing. Or if I have a phone number like this, that I want to copy into this other field and paste. It pastes the numbers, but none of the punctuation, spaces, or letters. That's our lesson on DocumentListener and DocumentFilter. This lesson's on JTextArea. JTextArea is a multi-line text component that doesn't support styled text. Or rather, you can set any font, font size, font style, foreground and background color you want, but all the text will be in that same style. I've written a program that has a flow layout panel containing a button. Let's add a JTextArea. JTextArea equals new JTextArea. We'll start off passing no parameters to the constructor. Now we'll add the JTextArea to this south panel that's laid out with flow layout. Just as with JList, it's standard practice to wrap a JTextArea inside a JScrollPane. So instead of directly adding TextArea here, we'll add new JScrollPane TextArea. This tiny thing is the JTextArea. Remember that flow layout tries to honor a component's preferred size. The preferred size of a JTextArea, or at least this particular text area the way we instantiated it, will be exactly big enough to hold its text. Right now there's no text. Let me type some in. Can't see anything yet, but if I resize the frame, the JTextArea will assume its preferred size for the text that I typed in. I'm going to type some more text. Notice the scroll bars appeared, and if I resize again, it will be laid out in this new size. If we're going to lay out a JTextArea with flow layout, or another layout manager that respects the preferred size, then we should specify the number of rows and columns in the constructor. So let's say 6 rows, 12 columns. This will set a preferred size with room for 6 rows and 12 columns. Actually, it's trickier than that, because the JTextArea is inside that JScrollPane, and actually the JScrollPane will get that preferred size. That's better. Notice that it keeps its size when the frame is resized. What I usually do, though, is to use a layout manager that ignores the JTextArea's preferred size and stretches it to fill available space. For example, the center of a border layout or a grid layout. So let me remove it from this flow layout panel and instead add it to this border layout panel. Then when we resize the frame, we also resize the text area. Scroll bars appear when they're necessary and disappear when they're not. If you'd like the JTextArea to be populated with text when it appears, pass a string as a first argument to the constructor, like this. While I'm here, let me delete the 6 rows and 12 columns. It doesn't have anything to do with passing in this text string. It's just that now that it's in the center of a border layout, specifying rows and columns is irrelevant, so I might as well delete them. I prepared the string here for this example. This string has 3 lines. They're separated by new line characters. This is the end of the first line. This is the end of the second line. This is the third line. If I were to do something like this and specify a carriage return in a new line, this would be a mistake, even if we're running on a platform where files are typically terminated this way. That's a file system issue, and it'll be relevant later when we do I/O, but where a swing component stores its text internally in its document, line endings are always represented with new lines. So here are the 3 lines of that string. Often, we don't want the user to have to scroll like this. So JTextArea has a property called line wrap, which we can set to true. You'll notice that the lines have been wrapped, but not in the most user-friendly way. This word, authorities, is split on 2 different lines, as is this word and this word. To address this, JTextArea has another property called wrapStyleWord, which we can set to true. Setting wrapStyleWord to true doesn't have any effect unless line wrap is also set to true. That looks a lot nicer. Now let's say we want to save this text that the user has edited to a file on the disk. All swing text components have a write method that can do that, and also a read method. Let's create a listener for this button that calls the write method. Let me rename the button Save Button. And because we're going to be dealing with files, let me import another package. Import java.io. First, let me set up a java.io.file object that will determine where on the disk this file will be saved. We could say new file and give it some path, like this. But what I think I'm going to do is call the createTempFile method. This will choose a temporary file somewhere appropriate on the file system. But this method is declared to throw I/O exception, which we need to catch. Okay, there's our file object. Now let's add an action listener to the Save button. What I'd really like to do here is to call Save Button, add action listener, then here to call TextArea's write method. Write, new file writer, temporary file. But there are 3 issues with this. First, we need to catch the I/O exceptions. Second, we need to close the writer after we're finished writing to it. And third, we should really wrap this file writer in a buffered writer for performance reasons. We can address all those issues with a Java 7 style try with resources block. The resource will be the writer. Let's name it out. New buffered writer, new file writer. We'll call TextArea's write method without, and we'll rethrow any IO exception. This call to write will attempt to convert the new lines in the TextArea's document to the appropriate line endings. If I instead had written this, out.write, and pass a string here, and the string I'll pass is TextArea.getText. This is legal, but it won't do any conversion. The new lines in the document will go straight into the file. So almost always, you'll want to call the write method instead. Reading a file is similar. Let me create a read button. And add it to the panel. And I'll use this writing code as a template for the reading code. Read button, reader, buffered reader, file reader. I'll call the TextArea's read method and pass it the reader. And this method also accepts a second parameter. The idea is that this is a description of the thing that's being read. So you could pass in, for instance, temporary file, the file object. Or it's also legal to pass in null. And for JTextArea, that's fine. If this were a fancier text component, like one that could handle hyperlinks, then we might want to pass in the base URL as a description, so it can handle relative hyperlinks. This read method will read the file, it will replace the contents of the TextArea with the contents of that file, and as it converts the file's line endings into plain new lines, it remembers what the original line endings were and stores that in the document. Then later, if we call write, it will look up what it had stored and convert back to those very same line endings. If write is called first, and no line endings have been stored yet, it will use the typical line endings for your computer's file system. Let me type some different text here. I've just clicked the Save to File button, so the event handler has saved the document. Now there's a file on the disk that contains the text. This is the story of the hare who lost his spectacles, 1, 2, 3, 4. Now if I click on this Read from File button, it will retrieve the contents of that file and place it into the TextArea's document. That's our lesson on JTextArea. But again, these read and write methods work for any swing text component, not just JTextArea. This lesson's on JTextPane. JTextPane is a multi-line text component that supports multiple styles. Let's add one to this program. JTextPane, textPane equals new JTextPane. Other swing components allow us to specify the initial text as an argument to the constructor. But JTextPane doesn't have a constructor like that. So if we want to set some initial text, we can just call textPane.setText. I have a string here with lines separated by new lines to set for the text. We'll add it to the panel. And just as with JTextArea, we want to make sure that we place the JTextPane inside a JScrollPane. We'll add it to center. All the text is in the same style, but let's change that. This stage direction and this stage direction to be a different style. The first thing we need to do is import a new package, javox.swing.text. This package contains most of the style-related classes. We need to instantiate an attribute set, assign some attributes to the attribute set, and then apply the attribute set to segments of the text within the text pane. Simple attribute set is a class that implements the attribute set interface. So we'll instantiate one here. New simple attribute set. Now we'll assign some attributes to this attribute set. The easiest way to do that is to use some utility functions defined by the styleConstants class. We'll say styleConstants. Let's say set italic. First thing we do is we give the attribute set we want to set this attribute onto. And then we need to set the value for italic, in this case true. Let me set a couple other properties. Set font family, serif, and let's set the font size. So now that we've configured our attribute set, we'd like to apply that to some regions within the JTextPane. The way we do that is by calling textPane.getStyledDocument. If we called textPane.getDocument, it would actually return the same object as getStyledDocument. But the return type of getStyledDocument is StyledDocument, which has some extra methods that the document interface does not expose. One of those is called setCharacterAttributes. We specify the index into the document where we want these attributes to be applied, the length that we want them to be applied for, 14 characters in this case, the attribute set. And now either true or false for whether we want to replace the existing attribute set. For now, I'm going to say false. I'm going to do the same thing for another region, starting at 157 with a length of 116. Here are our italic sections. Let me call the select method within TextPane. Specify an offset into the document for the beginning, and then another offset for the end. So this is a beginning offset, this is an end offset, which is different from this method, where this is an offset, this is a length. If I run this, characters from 31 to 39 will be selected. There they are. The reason I mention it is because if we call a method called replaceSelection with some other string, this will replace the selected text with this newly provided text. So it says inserted here instead of estragon. If there is no selection, then this replaceSelection method will just insert text at the caret position. Because no text was selected, the string was inserted into the text without replacing anything. So the name of this method, replaceSelection, is somewhat misleading. If there is a selection, it'll replace it. Otherwise, it will insert. Notice that because position 165 was inside this italic text, the inserted string inherited that style and is italic. If I move it to a different spot, say 139, that's not in an italic section, then it'll be inserted and it will inherit the style of the insertion point. So this time it's not italic. That's how editing from the keyboard works too. If I type letters here on the keyboard, they'll be in the same style. Type them here, they'll be in the matching style. JTextPane keeps track of the style attributes associated with the current caret location. And if the caret location moves, because we click somewhere or we do it programmatically, then it adjusts. We can get a hold of that attribute set at the caret position by calling TextPane.getInputAttributes. This returns an attribute set, but it's live, and we can add additional attributes to the intermediate attributes set, and they'll be applied. So for instance, I can call styleConstants, set foreground, and apply to the input attributes color red. So we set the caret position, we get the input attributes at that position, we add a red foreground color to it, and now if we call replaceSelection, it will insert this text with the updated input attributes. And there's our text in red. Let me talk about another method. It's called InsertIcon. The name looks very different from replaceSelection, but they both do the same thing. If some text is selected, both of these methods will replace it with something else. And if no text is selected, both of these will insert the new object at the caret location. But while replaceSelection takes a string, InsertIcon takes an icon. If we call newImageIcon and give it the file name of a JPEG or a GIF, then it will insert that image into the text pane. Or I can call newBallIcon. And there's the icon inserted into the document. There's one more method like these two. Let me first move the caret position to the end of the document, calling TextPane.getDocument, getLength. And the third method is InsertComponent. And here we can give it any component, including swing components, and that component will appear in the text pane. So for instance, we could say new JButton, and there's the button. It's live. It reacts when I mouse over, and if I click on it, it clicks. It's kind of cool that this is possible, even though it's not useful very often. Next thing I'd like to show you is name style. So let me make a style called CharacterHead. And the way you style is an interface with no obvious class that implements that interface. The way you can get one is by calling TextPane.addStyle. And we can give it a parent style if we wanted to have a hierarchical structure, or we can just say null for the parent. Even though this method is called addStyle, what it really does is create a new style and return it. A style is similar to an attribute set. In fact, the style interface is a sub-interface of the attribute set interface. So the set methods within styleConstants can be applied to styles also. styleConstants set something called space above. give the name of our style. And this is the number of points of space we'd like to appear above the paragraph. So let's say 6 points. Let me set the indentation on the left side, 36 points. Let me set a color of the text. Set foreground, char head, color dot, do dark orange. I should mention that there are two different kinds of attributes. There are character attributes and there are paragraph attributes. Character attributes are foreground color, font size, italic, bold, underline, strike through, subscript, and superscript. Where the paragraph attributes are alignment, left indent, right indent, first line indent, line spacing, space above, space below, and the locations of tabs. You set them into an attribute set or a style the same way using these setter methods inside style constants. But the set character attributes method essentially only cares about the character attributes and ignores the paragraph attributes. But if I call a different method called setLogicalStyle, I give an index into the document. This method will apply this name style to the entire paragraph that contains this offset. So this offset can be the first character of the paragraph, which is what 0 is, or it could be near the end of the paragraph and it would have the same effect. So let me apply this to a few more paragraphs. You can see these 4 paragraphs are in a different color, left indentation, and have some space above. What's neat about name styles is that the document will listen for changes in them. So for instance, let's say instead of setting the foreground color before the setLogicalStyle calls, I do it afterwards. So when this call occurs, charhead has space above and left indent, but it doesn't have a color. And then I add the color later, but it'll work fine. Because the JTextPane pays attention to any name styles that have been assigned to paragraphs. If I try the same thing up here, let's say I move this set italic call, so it occurs after the calls to set character attributes. Then this will not work, because it's only the attributes that are in the set at the time of the call that will be applied. See, this is not italic. And that's the difference between how name styles and attribute sets are treated. In fact, I can put a listener on this button that modifies that style object. So down here I can say button.addActionListener. So I can call style constants, set bold on the character head. So I can get the current value of bold. I'm calling style constants is bold character head. And then I can use the not operator to flip it. Now when I push this button, it modifies the style. The JTextPane notices the modification and renders the text in the modified style. As I mentioned before, the style interface is a sub-interface of the attribute set interface. What that means is I can use a style, like character head, as an attribute set. But the JTextPane will not notice a change if I use it as an attribute set. So let me call TextPane getStyleDocument, set character attributes, offset 180, length 13, character head will be our attribute set, and false for replacement. So here's 180, length 13. Notice that it did apply the character attributes of the style, which is the foreground color. It did not apply the left indent and the space above because those are paragraph attributes, not character attributes. And if I click the button to change the style, these paragraphs, which were set to use that style, are updated, but this text is not. Even though we passed in a style as a parameter, the setCharacterAttributes method does not register listeners on it. Notice that this hearty laugh text, it's still italic, and that's because we said false for replace. So it's going to take attributes in this attribute set and apply them on top of the attributes that are already there. But if I say true for replacement, it will get rid of any attributes that are already on that text and instead use the attributes in this attribute set. Passing true for that parameter removes the italicness from that text. That's our lesson on JTextPane. This lesson's on JEditorPane. I've written a program that has a panel using border layout. Let's add a JEditorPane to this. We could pass a single URL to the constructor for JEditorPane, or we can provide 2 parameters, the first of which is a content type, using MIME syntax, and then the string for the contents. I've created a multi-line string here. Let's add the JEditorPane to the main panel. As usual with multi-line text components, we want to wrap the JEditorPane inside of JScrollPane. Here's my text. So far, it's a lot like a JTextArea or a JTextPane, but we can change that by specifying a different content type from TextPlane. JEditorPane supports 3 content types: text/plain, text/RTF for rich text format documents, and text/HTML for HTML. Now, I really need to emphasize that for RTF and for HTML, it doesn't support everything. It supports simple HTML and simple RTF, but anything real complex, JEditorPane just is not prepared to handle. But this markup is fine. Here's an ordered list, here's some links, here's some text in different font styles, here's an animated image. It is unfortunate that I needed to scroll up to the top. The reason it appeared on the bottom is because after loading all the text, the caret is located at the end of the document, and so it scrolls to make sure that we can see the caret. So the way to fix that is just to call set caret position 0 on the editor pane. This moves the caret to just before the first character, so we see the top part of the document. By default, the JEditorPane is editable, which means I can click and add characters or delete. Even this hyperlink, if I click on it, I can add characters. If you want to prevent the user from doing this, we can call setEditable false. And now when I click on this header, I can select words, but I can't edit them. When I hover over the hyperlink, the pointer changes. I can click on it. Clicking on it doesn't do anything right now, so let's add code to detect those clicks. First thing I'm going to do is import some more packages. The hyperlink event class is in the javax.swing.event package. I also want to import java.io. We need to call add hyperlink listener on the editor pane. Now this listener will be called whenever the user puts the pointer over a link, moves the pointer off of a link, or clicks on a link. And so if we want to handle only the clicking case, then we're going to need an if statement. Take the hyperlink event and call getEventType and see if this is equal to hyperlink event.eventType.activated. Let me put in a try catch here. Typically, what you want to do when the user types on a hyperlink is to call editorPane.setPage and give the URL e.getURL. SetPage will obtain the contents of the URL and set it into the editor pane. It does the same thing that calling the one argument constructor would have done. But a problem is that there's no guarantee that e is not null. Calling getURL on e might cause a null pointer exception. So we want to catch that. Else, call eGetDescription. So if the JEditorPane is able to understand the link, then getURL will return non-null, and we can call setPage. Otherwise, getURL will return null, but getDescription will return the link's text, even if it wasn't able to convert it to a URL. So now when I click on this link, the console will say, we'll attempt to display this URL, and it loads it. The reason I chose the Stallman site is because he uses very simple HTML that JEditorPane has no problem understanding. If I went to, say, google.com, which outwardly looks like a simple website, it can't handle a lot of the behind-the-scenes stuff that Google's website tries to do. So I can click on further links, and again, it'll call our hyperlink listener. There's no back button, because we haven't written one, so let me relaunch it. So I want to show some links I wrote down here. If I click on this, it'll say URL couldn't be formed from L:1, which is reasonable because L is not a valid protocol. But if we want our application to be able to react in some way to clicking on these links, we can do that right here in the event handler. We could say right here, if e.getDescription equals L:1, then do this. Else, if it equals L:2, do that. But let me write some code here to explain something about character sets. So if I call editorPane.setContentType, this will replace the current contents of the editor pane with an empty content with this type, text/plain. Let me set a bigger font. Let's do sans serif, plain, 36 point. And let me call editorPane.read. We've seen the read method before. We can pass in either an input stream or a reader as a first parameter, and a description, which can be null for the second parameter. Now, if I pass in a reader, character set is not really an issue. So if I pass in an input stream, there are multiple ways that the bytes can be interpreted as characters. So you might need to be careful. Here are some bytes that I've selected that we can try to read. So let me call new byte array input stream and give it those bytes that I showed you. This code will interpret those bytes using the system's default character set, which can vary depending on your operating system and what part of the world you're in. But if you want to specify manually which character set to use, for the content type, you can say text/plain or text/HTML, either one, and a semicolon, and then say char set equals, and give the name of a char set. So for instance, I could specify shift JIS, which is one of several Japanese encodings. When I click on this, that code will be called. It will interpret those bytes using shift JIS and obtain these Japanese characters. Or, if I specify ISO 8859_5, which is one of several Cyrillic encodings. Now when I click, we'll interpret those bytes using the ISO 8859-5 encoding, resulting in these Cyrillic characters. This character set issue is just something to be aware of. That's our lesson on JEditorPane. This lesson is on creating a table model. The swing table component is called JTable, so let's create one. New JTable. JTable provides a couple constructors that allow you to directly provide the data you want displayed. One takes a two-dimensional array of objects, and the other takes a java.util.vector of other vectors. But I recommend that you never use those two constructors, and instead use a constructor that takes one parameter, which is a table model. That does mean we need to write a table model, but it's a pretty simple thing to do. Just 4 or 5 simple methods to get started. First, let me import a package we're going to need, javax.swing.table.star. And I'll create a table model. The key is to extend abstract table model. Abstract table model provides a lot of the plumbing that we would otherwise have to write. To be polite, I'll create a serial version UID, but it's not required that you do this. The first method we need to write is called getRowCount, and we simply return the number of rows we want on the table. Next method is called getColumnCount, and we simply return the number of columns that we want, and say 2. Next method is called getColumnName. Given a column number starting at 0, we simply return a string for the name of that column. A switch statement might be overkill for a table model with only 2 columns, but I'll do it anyway because it's easily extended for a table model with arbitrary columns. For the first column, column number 0, I'll return the string integer, and for the next column, I'll return string parity, and it shouldn't be any other value, but if it is, we'll return null. The fourth method is called getValueAt. This method returns the values that will actually be presented in the table. The parameters are the row index and the column index, and we return an object for the value of the cell at that row and column. I'll use the switch statement again. So for the first column, I just want to return the row number. That will be boxed to integer value of row. We could have specified it that way. For the second column, a string, either even or odd. Column index shouldn't be anything besides 0 or 1, but we'll just return null if it happens to be. Now there's one more method we'll probably want to write. But these 4 methods, getRowCount, getColumnCount, getColumnName, and getValueAt, are sometimes all that's needed. So let me pass into the JTable constructor, new integer table model. Let me add the table to my main panel. As with many other Swing components, JTable is intended to be placed within a JScrollPane. We'll say new JScrollPane table. There's the JTable with our 25 rows. Notice that the parity column is left aligned, and also the integer column is left aligned. We can change that by writing one more method in our table model called getColumnClass. Given a column index, we return the type of that column. For the first column, we can return integer.class. The second column, we can return string.class. We could return null here. Well, let's be a little more polite and return object.class. That's what the implementation of this method in abstract table model does. This returns objects.class for everything. Now the idea is, if we return a specific type for the column class, like integer, that it can display that value in a specialized way for that type. What it does for numeric types is it right aligns them. And there's a few other types that it knows how to handle also, which we'll get to later. But I want to point out that you're allowed to lie in the getColumnClass method. So for instance, I can say column number 0 is a string, even though it's not, it's an integer. And I can say that column index number 1 is an integer, even though it's not, it's a string. And if I run this, it left aligns what it thinks are strings, and it right aligns what it thinks are integers. Usually it makes sense to tell the truth, so let me switch this back. But sometimes it makes sense to lie here. In particular, if you want something to be right aligned, you can just give it a numeric type in the getColumnClass method. Let me do one last thing, and that is to change the row count to a much larger number. Let's say 2 million. And you'll see this table really does have 2 million rows. But JTable is not storing values for 2 million rows. What JTable does is simply call getValueAt on the table model whenever it needs a value. And then it throws it away, and if it needs it again, it asks for it again. So if I quickly scroll to about 400,000, it didn't call getValueAt for all those intermediate rows. It only called getValueAt for these rows that are displayed, plus maybe a few that were briefly displayed as we scrolled through that. That's our lesson on creating a table model. This lesson's on creating an editable table model. I've written the skeleton of a table model called color table model, extending abstract table model, with the methods we saw last time: get row count, get column count, get column name, get column class, and get value at. I just haven't written the details of the methods yet. So let me instantiate a color table model, and pass it to the constructor of JTable. New color table model, and I'll pass in an array of colors to the constructor. Here's an array I have prepared already. Let me create a field to hold the colors and create a constructor. Rows equals colors. We'll implement all of these table model methods using this array of colors. So get row count. We'll return rows.length. How many ever colors we have in the array, that's how many rows we have. For column count, I'm going to return 5. The column names, first one will be red, the red component of the color. Similarly, columns 1 and 2 will be green and blue. Shaded ball for 3, and for the last one, achromatic. Let me put getColumnClass on hold. For column 0, we want to take the row being requested and return its red component. Similarly, for columns 1 and 2, we want the green component and the blue component. Those are all ints that will be boxed into integers. For column 3, I'm going to return an icon, size 13, using the color for that row. And for column 4, achromatic, I'm going to return true if it's a shade of gray and false otherwise. So I need to check and see if the red, green, and blue components are all the same. So we'll compare red and green, and we'll compare red and blue. Let's see how it looks. So here's our table. For the achromatic column, the Boolean values are being rendered as strings, and this icon is also being rendered as a string. This is what the toString method of the ballIcon class returns. But Booleans and icons, any kind of icon, not just a ball icon, for instance, an image icon would work well, are supported so long as we return the right value from the getColumnClass method. For columns 0, 1, and 2, we want to return integer.class. For column 3, we want to return icon.class. For column 4, we want to return boolean.class. And now we see the icon in column number 3, and we see checkboxes in column number 4. A checked box representing true and an unchecked box representing false. This table is read-only. If I want to change this number 0, if I double-click, type on the keyboard, nothing happens. But we can change that by adding 2 more methods to our table model. The first method is called isCellEditable. And we simply return true if we want the user to be able to edit the column and false otherwise. So for this example, let's make the first 3 columns, the red, green, and blue columns, editable. We also need to write one more method, but let's try running it. Now if I double-click on this cell, I can type things into it. But if I hit return, it doesn't stick. The cells are editable, but without the final method, it doesn't do anything. By the way, if I made this column editable, then I could change these checkboxes by clicking on them. So what is that final method? It's called setValueAt. It takes the value that's being set in and the row and column index for where it should go. Since these three columns are integer columns, the type of value will be an integer, but the parameter type is declared to be object. So we'll have to cast it to an integer or to integer's superclass number. Just for convenience, I'll create a variable to hold the previous unedited value of the color at this row. Now let me instantiate a new color object with the new value. So we'll call new color, and for red, we want to use value if column is 0, but the previous value for red if the column is not. So we can say, if column is 0, use n, otherwise use old.getRed. And for green, if column is equal to 1, we'll use n, otherwise we'll use old.getGreen. And finally, if column is equal to 2, we'll use n for blue, otherwise old.getBlue. Now, it may be that the user has typed in a value that's exactly the same as the one that was there before. If that's the case, we don't need to do anything further. So I'll check and make sure they're different. If not, new color equals old. Then we need to do two things. One is we need to store the new color in our array so that we can return it from getValueAt whenever the JTable asks for it. So we'll assign to rows row equals the new color. But there's a second thing you need to do in setValueAt, and that is to fire an event to notify all listeners, and the JTable is a listener of the table model, to notify all listeners which cells have changed and might need to be updated. Abstract table model provides a bunch of methods that start with the word fire. Fire table rows deleted, fire table changed, fire table cell updated, fire table rows inserted, fire table rows updated, file table structure changed. So we could call fire table cell updated with row and column. But this isn't quite good enough. And let's see why. So let's say I want to change this number. I'll double click on it. I'll change it to 8 and I'll hit return. This value is registering as 8. But we'd like this icon to change color. But because we never fired an event mentioning this cell, the table didn't know it needed to be updated. We could force it to be updated by, say, hiding it and bringing it back. Now it's a lovely shade of green, but we'd like that to happen automatically. Similarly, if I happen to change all three of these to make it a shade of gray, we'd like this box to be checked automatically. So in the setValue method, I need to take that into account. So one thing I could do is fire 3 events. Column number 3 for the color, and column number 4 for the achromatic checkbox. Now it may be we could add some logic to only fire the table cell updated event for column 4 if the status of the Boolean actually changed. Or we can just do this and fire an event every single time and it'll refresh it, possibly with the same value it already had. Let's take a look. You can hit return and this icon changed automatically. But for this particular case, it might be easier to, instead of calling fire table cell updated 3 times, just call fire table rows updated. This takes a range of rows. In our case, just a single row. So it's the range from index row to index row. Firing this event will cause the JTable to refresh the entire row. So if I change this value to 175, hit return, I'll expect the shaded ball column and the achromatic column to both change. And they do. That's our lesson on editable table models. This lesson's on JTable. JTable has several properties that can be set, and in this lesson we'll explore many of them. As you can see in this program, the stock JTable allows the user to resize any of the columns, and also to reorder the columns by dragging them with the mouse. Sometimes that can be handy, but other times you'd like to disable it. And we can do that by calling table, getTableHeader, set reordering allowed, false. We could also call table, getTableHeader, set resizing allowed, and that would prevent the user from resizing any of the columns. I'll comment this out though, because I want to explore more about how columns are sized. So now I'm trying to drag this column to reorder it, but it's not allowed. For sizing, notice that each of the 5 columns is given the same width. And if I resize the width of the table, that remains true. If I resize one of the columns larger, other columns get smaller to adjust. The total width of all the columns remains the same. Again, sometimes that's what you want, but sometimes you'd like to put it into a different mode. We can call table set auto resize mode, give it the value auto resize off. JTable supports several resize modes, but the two that are commonly used are the default mode and this off mode. In the off mode, every column is given a fixed width, and in this case it doesn't even fill the width of the table. In this mode, if I resize a column, the other columns remain the same size, and I can push it off the edge and cause the scroll bar to appear. This is probably what you want if your table has a lot of columns. Now what if you don't want all the columns to be the same size when they first appear? We can set widths for individual columns. We need to call a method to get a reference to a table column and then set values into the table column. One way to get a table column is called table getColumn. This takes a row identifier. So in this case we could say blue because that is the title of one of our columns, and say set preferred width and say 45 pixels. And see how the blue column has size differently. But I usually prefer to use integers instead of names. And I can do that too, it just takes an extra step. We call table getColumn model, then getColumn and give the index. Blue is our third column, index number 2. And then I can call set preferred width. I can also call set min width and set max width. Let's say I want min width to be 30 pixels and max width to be 75 pixels. I'm trying to drag blue smaller, but it's stopping at our minimum of 30. And if I try to drag it bigger, it will stop when it gets to our maximum of 75. Since we haven't set green, it can go pretty small or arbitrarily large. Often what you want to do is set an initial width for all of the columns. So you loop through 0, 1, 2, 3, 4. And give columns that need lots of space a large width, and give columns that don't need a lot of space a narrow width. Something else we can do with a JTable is turn off the grid lines. Call set show grid false. Now the grid lines don't appear. There are also methods called show horizontal lines and show vertical lines. So you can set one to true and one to false if you only wanted one set of lines to appear. We can also set a custom color for the grid. Set grid color. Let's say color.pink to have pink grid lines. We could also call table set selection background. Let's say color.yellow. There are our pink lines. There's our yellow selection. Notice that clicking on a cell selects the entire row. That's the default behavior, but we can change that. We call set row selection allowed false to turn off row selection. And we can call table set column selection allowed to true. Now we select columns. Or we can call table.set cell selection enabled. Calling set cell selection enabled true is equivalent to calling set row selection allowed true and set column selection allowed true. Now we can select individual cells. Or I can drag, select a rectangular region. By holding the Control or Command key, I can deselect some cells or select others. But you'll see the behavior is a little weird. It keeps track of which rows are selected separately from which columns are selected. There's no way to deselect a column on one row without also deselecting it on all the other rows. If you don't like that, you can call table.setSelectionMode. This method accepts a constant that's defined in the list selection model class. So you say list selection model dot, and we could say single selection. If we were to run this, we would only be able to select a single cell. Or we can set it to single interval selection. And this will allow us to select a rectangular region, but only one contiguous rectangular region. By default, if I click in the middle of these column headers, a default JTable won't do anything. But if we'd like to be able to use a column to sort the rows, we can do that. The simplest way is to call the setAutoCreateRowSorter method. Now if I click on red, it will sort all the rows from low red values to high red values. And if I click on it again, the sort order will flip, so it's from high to low. And same for green or blue. If I click on the achromatic column, it will sort from false to true, or if I click again, from true to false. If I click on the shaded ball column, it will actually sort it. What it's doing is calling toString on the value of the column, which in this case is an icon. If we really wanted to, we could create a custom comparator for this column and set it. Or we can simply prevent this column from being sorted. To do that is a little more complicated than calling setAutoCreateRowSorter true. First, we instantiate a table row sorter, and we pass it our table model. Now that we have a row sorter, we can set it into the table by calling table setRowSorter. These two lines together are equivalent to this line. But the difference is now we have our row sorter and we can do things with it. So for instance, we could call row sorter set sortable, say column 3, which is the icon column, false. And now I'm clicking on this column header, but it's not sorting. One last thing I should mention is that even though this class is called table row sorter, it also can do filtering. So for instance, I could call row sorter set row filter and pass in rowFilter.numberFilter, rowFilter.comparisonType.equal, and some numeric value, let's say 255, and I could pass in one or more var_args column indices. Or if I just don't specify any indices, then what this filter will do is include any row that has a 255 in any column whatsoever. And you can see all of the colors listed have a 255 in one of these 3 columns. And all the colors that don't have a 255 anywhere aren't even listed in this table because of the filter. If you want to filter for strings instead of for numbers, instead of calling rowFilter.numberFilter, you can call rowFilter.regexFilter and give it a regular expression. That's our lesson on the JTable class and its properties. This lesson's on table events. I've written a program with the JTable that uses a table model called Person Table Model. Let's take a look. It uses this simple class called Person with these 3 fields, title, forename, and surname. I probably should have written getters and setters for those fields, but for brevity I did not. And then here's the table model. It has an array list of person. And so the row count is just the size of that list. And there's 3 columns, title, forename, and surname. And getValueAt returns the title for column 0, the forename for column 1, and the surname for column 2. And similarly, in setValueAt, we set those fields. So there's our JTable. Now let's say we want these buttons to do something. Let's say we want this button to add a new row to the table. We can do that. We'll add an action listener to this button. And let's call the addRow method in our table model. So the table model is called Person Table Model. And we'll call addRow, which is a method we haven't written yet. And let's pass in a person to be added. So the row we will add 3 null strings. Now let's implement addRow in our table model. It's called addRow. It takes a person. So we'll append this new person to the end of our array list, calling the add method. So now it's been added to our array. We need to fire a table row insertion event. So we'll call the method fireTableRowsInserted. We have to pass in 2 row indexes. This method takes a lower row index and an upper row index of the rows inserted. Since we're only inserting 1 row, the lower and upper index will be the same. And we could call people.size -1 to get the last index. Or I can just get the last index. Or I can just get the size of the array list before I add the new row. Then I don't have to subtract 1. So we'll get the size, we'll add the row, and then we'll use this index for firing our events. Now when I click this button, a new row will appear, and I can edit it if I wish. Let's change this button to delete a row. So let me add a delete row method to my table model. That takes a row index, the row to be deleted. We'll do some range checking on that index. And if the index is valid, we'll remove that row from the array list by calling people.remove. And again, we need to fire an event. So the JTable will realize that the row is gone and adjust its display. So the method here is called fireTableRowsDeleted. And again, we give it a range of rows that have been deleted. In this case, there's only 1 row, so the low index and the high index will be the same. Now let's write the code that calls this method. Now we're going to need some code to figure out which row should be deleted. So let's ask the table which row is selected. We're calling getSelectedRow. If multiple rows are selected, this will just return the first selected row. But if no rows are selected, then it will return -1. So we need to catch that. So if it's 0 or greater, then we can call deleteRow on the table model. Now this isn't quite correct, and let's see why. So if I want to delete Captain Crunch, I can select that row and click this button, and Captain Crunch is gone. So it appears to be working. Well, the problem is, if I sort the rows, and if I want to delete Mrs. Butterworth, it didn't work. Mrs. Butterworth is still there, and it deleted another row. And the reason for that is that this index is the index in the view, and we need to convert that to the model index before we pass it into deleteRow. To make that clear, let me call this viewIndex. And JTable provides a method to convert the row index. It's called convertRowIndex to model. And now if I sort and delete Mrs. Butterworth, it works correctly. If you'd like to be dynamically notified whenever the selection changes, we can write event handlers for that. JTable keeps track of the row selections and the column selections separately. For the row selection, we call table getSelectionModel. It's simply called getSelectionModel, but this is for the rows. And we can add a list selection listener here. Almost always you'll want to check if getValue is adjusting. If it is adjusting, you can essentially ignore this event. But if it's not adjusting, then the selected rows have probably changed somewhere. We'll print out the selected rows here. The code for column selection changes is almost identical. Let me copy this to start. Instead of calling table.getSelectionModel, we want to call table.getColumnModel. Instead of calling getSelectedRows, we'll call getSelectedColumns. You can see the row selection is 4 and the column selection is 1. If I click on column number 2, I get a column event but not a row event. Now if I click on a different row, I get notified that the row changed. Or if I drag, again I'll be notified. I should point out that there's another listener we could add. We could call table.getColumnModel.addColumnModelListener. The argument should be of type TableColumnModelListener, which is an interface with 5 methods, including columnMoved for when the user reorders the columns by dragging, and columnMarginChanged, which will be notified whenever a column is resized. If you do register a column model listener, be prepared to get a lot of events. For instance, for the column moved, you'll get an event for every pixel that's dragged. So instead of being notified once that it's been resized, you'll get a continuous stream of resized notifications, and there's no notion of value is adjusting for that event. So it's a little cumbersome to listen to these events properly. Something else we could listen for on the JTable is mouse clicks. We can call table add mouse listener and provide a mouse listener. If we're only interested in mouse clicked events, it's easiest to pass in a mouse adapter where we override that one method. Public void mouse clicked. We can call e.getPoint, and that'll return the x and y location of the click. But typically, we don't want the x and y location, we want the row and column. So JTable provides methods to get those for us. So we can call table row@point, pass in e.getPoint, and that'll give us the row index clicked on, but the view row index. Similarly for column at point. Depending on what you want to do with this mouse clicked event, the view row and the view column might be adequate. But often you want the model row and the model column, so we can convert them. Convert row index to model, and convert column index to model. And then we can print out a message, and we'll get the value out of the table model by calling getValueAt, the model row, and the model column. So it says right here, user clicked on Chiquita. User clicked on Capped. User clicked on Whipple. Notice though, that if I click below the last row, I'm clicking right now, that we don't receive an event. That's because this area is actually not part of the JTable. It's part of the scroll pane that the JTable has been placed in. But sometimes you'd like to be notified of events in this area. So there's a method we can call called table set fills viewport height. But if we make it true, Then this area below the last row is part of the JTable. If I click on it, I get an exception. And that's because we have to be careful, because this view row will now be -1 to indicate that it wasn't on an actual row. And then when we call convert row index to model, that's what throws. So we just need to be able to handle that. And in fact, the same thing can happen with the column under some resizing modes. So let's check that too. Now if I click down here, it says user clicked outside a cell. That's our lesson on table events. This lesson's on cell editors. I have a JTable and it exhibits default behavior. So if I single click on a cell, the row containing that cell is selected. If I'd like to edit a cell, I need to double click on that cell. So I'm going to double click right here. And when that happens, the editor is invoked for this cell. In this case, it's a text field. So it grabs an editor, it configures it, and it places it within the boundaries of that cell so I can type. If you have a requirement where you need to be able to edit with a single click instead of a double click, we can handle that. First, we need to grab a reference to the existing editor that we want to change. So I'll call it existing editor. And we can call table.getDefaultEditor to get the editor that will be used for a particular class. So in this case, all 3 of our columns have string.class, and this will work. Or we could say object.class, because by default, JTable uses the same cell editor for strings or for any objects. Now that we have a reference to the existing editor, what we'd like to be able to do is call existingEditor.setClickCountToStart. But this won't compile, and that's because this method is not declared inside the table cell editor class. It's defined inside the default cell editor class. So we need to cast this to default cell editor. For our table, it's all we need to do because everything is a string. But we could do the same thing for all the other default editors that JTable has. So we could get the default editor for double.class. So if your table model had a column with a column class of double.class, you could call table.getDefaultEditor double.class and then call setClickCountToStart1 on that. You don't need to do this for boolean.class because that editor already reacts to a single click. Now if I put a single click on this cell, it opens for editing. Now let's say for this title column, instead of having the user type in a title, we want to present a combo box. What we need to do is create a cell editor that behaves like a combo box and have the table use it. So first let's create the JComboBox that we want to become the editor. New JComboBox. Mrs., Ms., Miss, Mr., Colonel, Captain. Now let's turn this into a table cell editor. Call it combo editor. We'll call new default cell editor, and we can pass in our JComboBox. Now I should make it clear that this doesn't work for any component. If you take a look at the constructors available for default cell editor, there's one that takes a checkbox, one that takes a combo box, which is the one we're calling, and one that takes a text field. So if you wanted to use some other component, like a JSlider or a JTextPane, this wouldn't work. You could still create an editor using a component, but you'd have to write more code to do it. You'd have to implement every method in the table cell editor interface, and there's quite a few, but it's certainly doable. But for our case, we can just use default cell editor. Now we need to instruct the JTable to actually use this editor. There's a couple ways we can do that. One is we can manually set it onto a column. So first let me get the column, table, get column model, get column, index 0 for the first column. And now that I have this column, I can call set cell editor and pass in my combo editor. Now when I click, a combo box appears and I can choose something else from the list. You'll notice there isn't quite enough room to show the combo box in a pretty way. This text is being clipped on the bottom. So we can fix that by adjusting the cell height of the table. Also, if we wanted, we could make it so we could type in a title that's not listed. To change the row height, we can just say table, set row height, say 20 pixels. And to allow the user to type in another title, we can just say editor box, set editable, true. Now the combo box looks a little better, and we can type in. Let me comment that out. And let me comment this out to show you another way to instruct the JTable to use this editor. And that is to call table.setDefaultEditor. This takes 2 parameters. The first one is a class object, so we can say string.class. And the second is our editor. And what this does is this registers with the table that this editor should be used with columns of this class. So if I run this, our ComboBox editor will be associated with this column because this column has a column class of string, but the other two also have column classes of string. And so it's associating our editor with all three columns. Sometimes that's what you want, but in this case it's not. And so we can fix that a couple ways. One is we can go down to our table model, get column class method, and return object.class for these two columns. Since we registered this editor with string and not with object, this will work. So I have my normal editor here, and only the combo editor here. Or we could do it another way. Let me turn these back to string. And we could just choose another class for column 0, the special column. Like for instance, we could return stringbuffer.class. Now this is a lie, but you're allowed to lie and get column class. And then we could register our editor with a stringbuffer.class. Or why don't we use the person.class? Person is this nested class right here. This is still a lie because the value of that column is really a string, but you're allowed to lie. And so we change this to person.class. And as you can see, that also works. That's our lesson on cell editors. This lesson's on cell renderers. We have this JTable with a ComboBox editor for this title column. So when we click on it to activate the editor, it looks like a combo box. But when we're not editing a cell, it doesn't look like a combo box. But we could change that. We could create a renderer for this column that looked like a combo box. And then when we clicked on it and the editor appeared, it could seamlessly turn into a combo box to maintain the illusion that it was a combo box all along. So let's write the code for that. The way you assign a renderer to a column is the same way that you do it for cell editors. So for instance, I could write table, get column, model, get column, set cell renderer, and pass in a combo box renderer. And that'll work fine. Or I can do it this way. I can call table, set default renderer, give it some class, in this case, person.class, because that's what the table model returns as the column class for that column. New combo box renderer. Either way will work. So let's write this combo box renderer class. Make it a nested class. And declare it to implement the table cell renderer interface. This interface only has one method. It returns a component, and it's called getTableCellRenderer component. And it takes a bunch of arguments. First, it takes a table. Then it takes the value of the cell we're rendering. It takes two booleans, one for if the cell is selected, or if the cell has focus. And then finally, the row index and the column index. And the idea is we can just return any component here, and it'll be used as the renderer for that cell. We could say return new JSlider, 0 minimum, 10 maximum, 5 current value. And we can run this. And all these cells are rendered with a slider. There's not really a slider there. If I click on it, it'll invoke our editor, and our editor remains a JComboBox. But it works. It's not a good idea, though, to instantiate a new component every time getTableCellRenderer component is called. Because this could be called a lot of times, especially if you have a big table. And you don't want to be creating all those components. What we would prefer to do, create one component or a handful of components and then return them over and over to be used as the renderer. So, create our JComboBox here. And then we'll return it here. But before we return it, we should configure it. Because if we don't, it looks like combo boxes, but there are no values set. So what we want to do is before we return it, call combo.setSelectedItem the value. The only problem with that, this value is not in the list that the JComboBox is prepared to display because we didn't pass any objects in. So what we do is call combo.addItem to make sure it's in there, and then after it's in there, select it. But an issue with this is that the number of items that have been added to the combo box could get huge. If this table had thousands of rows, or if this renderer were used for multiple tables. And since it's used to render one cell at a time, it only needs to contain the value for that one cell. So what we can do is we can say combo remove all items to remove everything, and then add the item. And in fact, we don't even need to call this because add item will automatically select the item if it's the only item. And now we can see all our titles, and we can change them And even though the renderer and the editor are different components, they give the impression of being a single component. One thing you'll notice, the forename and surname columns shade the selected row in a blue color, but our title column is not showing that selection. If you're happy with that behavior, you can leave it like that. Or we can put in some code to show the selection. Simply call combo set background color, and if it's selected, pass in the selection background color set into the table. If it's not selected, we have to set something. So we could try null, but that's not going to be pretty. So now you see the selected rows show up as shaded blue on our combo box column, but the other columns are an unnatural white color because we've lost the background color that it used to have. So one way to handle that is to just grab the color by calling getBackground and save that color in this field and then pass that field in. And now they look like they used to look, and if we select some rows, they become shaded. There's just one more thing I want to mention, and that is that this object, which is being used as the cell renderer, has a bunch of methods that it inherits from component and JComponent that aren't relevant to a cell renderer. We might override some methods here. So for instance, override the method invalidate, validate, revalidate, and repaint. There's actually multiple repaint methods. And those could all be overridden with methods that had no body, that just did nothing. And it might be slightly faster to do that. But for this simple example, we don't need to do that. That's our lesson on cell renderers. This lesson's on JOptionPane. The JOptionPane class has lots of methods, but I'm only going to discuss 3 of them, 3 families of static utility methods, because each one is overloaded several times. The 3 methods are called showMessageDialog, showConfirmDialog, and showInputDialog, and all 3 will pop up a modal dialog. I've written a program with 4 buttons, each one with an event handler. So let's look at the sleepy event handler. Here's button B1, sleepy, and here's the event handler. I'm calling JOptionPane showMessageDialog in the event handler, and I'm giving it 2 arguments. The first argument is called the parent component, and it's used to determine where the dialog should be placed. And the second argument is the message, which is often just a simple string, like this one. So when the user clicks on the sleepy button, a dialog will pop up that says you are getting very sleepy. Notice that it's centered on the main panel. That's because I specified the main panel as the parent component. But if I change this to say the sleepy button itself, then when I run it, it's going to center the dialog on top of this sleepy button, like this. Notice that the title of the dialog is a message, and this icon displays an I to indicate an informational message. Those are both configurable. First, let me change this back to main panel, because I think that looks a little better. And let me copy this call and add 2 more arguments. The third argument will be the title for the dialog. I'll say notice. And the fourth will be the message type. Here are the possible message types. In theory, the look and feel can do whatever it wants with these message types. But in practice, all it changes is that icon. So information message will have that I icon. Question message will have a question mark icon. Warning message will have an exclamation point icon. An error message will have an X or a stop sign icon, something like that. Whatever the look and feel thinks is appropriate. And plain message will have no icon. So if I specify JOptionPane.warningMessage, we'll see an exclamation point icon. I should also point out that it's possible to provide a 5th argument, which is an icon, any icon. But for instance, we could say new image icon. And it would use that icon in place of any of the ones that would be specified with the message type, which essentially means this 4th parameter would be ignored. There's our exclamation point icon. I've been dismissing these dialogs with the OK button, but you'll notice there's a close button up here. Most look and feels will provide a close button, and if the user clicks on the close button, that will also dismiss the dialog. With the showMessageDialog method, there's no way to determine which way the user chose to dismiss the dialog, but that's not true of the other ones. Let me copy this call to showMessageDialog so I can paste it into the B2 event handler. Now the B1 event handler, M was just a string, but I've declared M here to be an array of objects. And the array contains strings like this one, but also references to these three text fields in this slider that I've created. But it also contains some swing components that I've instantiated above, 3 text fields and a slider. And showMessage dialog and all the other methods can handle a message of this type with no problem. Let me change the dialog title to accusation. Let me change the message type to question message. Let me click on the B2 button. You can see that it rendered each of the objects in the message array on a separate line. So IQs is the first string, and this is the JText field I called who. Then this is the next string, and this is the next component. The next string, and the next component, with certainty, and then here's the JSlider. When I dismiss this dialog, either with the close button or the OK button, the event handler will resume and will continue with this system out print line message, which refers to the values stored in those J components. So it prints out Colonel Mustard in the conservatory with the lead pipe with certainty 2. So using these complicated messages, it's possible to do a lot with JOptionPane. Let's look at the B3 event handler. In this handler, I'm calling JOptionPane.showConfirm dialog. And again, it takes a component parent and a message. A difference from showMessage dialog is that it returns a value, an integer, which I'm storing in a variable called result. Let's take a look at this. It says, are you hungry? By default, I get the question icon. The title of the dialog is select an option, and it presents 3 buttons, yes, no, and cancel. And the return type depends on which button I push. So if I click on no, this result will be equal to JOptionPane.noOption. And if I use the close box, it will be equal to JOptionPane.closedOption. Similarly, if it's cancel, it will be equal to JOptionPane.cancelOption. And if it's yes, it'll be JOptionPane.yesOption. Now just with showMessage dialog, I can add more arguments to this call. So again, the third argument will be the title for the dialog. It's a type. And the fourth will be the option type. These are the supported option types, and they determine which buttons in the dialog. So if I specify JOptionPane, yes, no option, then there'll be no cancel button. Just yes and no. Of course, I can still cancel this way. If I were to instead have chosen OK cancel option, then there would be no yes button. There'd be an OK button. And so I could change this to OK option and this to OK. But it turns out that JOptionPane.OK option and JOptionPane.yes option have the same value. So for instance, if you were putting these in a switch statement and you listed one case for JOptionPane.yes option and another case for JOptionPane.OK option, the compiler would flag an error because you have the same case twice. Just as with showMessage dialog, it's possible to provide a fifth parameter, which would be the icon. Let's look at the fourth event handler. It calls JOptionPane.showInput dialog, again with 2 arguments. The first one is the parent component and the second one is the message. In this case, the message is the string, what is your name? This dialog shows our message, but also contains a text field in which we can type. So if I click OK, the value I typed in will go into this variable result, which is now a string, not an integer. And I print it out, so it says name is Horatio. Notice that the dialog title is input, and the icon is a question mark icon. I'm going to hit the cancel button this time, and it says name is null. Even though I typed a value into the field, when I hit the cancel button, it stored null into result. If I want that text field to be populated with some text, I can add an argument to showInput dialog. So let's say I want it to say Abe. Now it says Abe. But if I want to specify the title for the dialog, then I need to pass 4 arguments. And the third one will not be initial text for the text field, but will be the dialog title, saying moniker. And the fourth one will be the message type, just as with showMessage dialog method. So for instance, I can say error message. The dialog title is moniker, and the icon is the error icon. I can provide even more arguments. The next one would be the icon to use. So I could say new image icon, and provide an icon. Or I can just specify null for the icon, which means it'll use the appropriate one for the message type. Let me change this back to a question message. The sixth parameter will be an array of choices. This can be an array of arbitrary type, but I'll just use strings. So we pass in an array of strings and give any number of choices here. Abe, Barb, Carl, Dan. And the seventh parameter will be which one of those should be initially selected. So I could say Carl. Now you'll notice the compiler is flagging an error. And the reason for that is that the return type of this 7-argument showInputDialog method is not string, but is object. Because this array can be of any type, and it will return one of the values in this array, and so the return type has to be object. Or if the user cancels, it will return null. It decided to create a combo box with our 4 items. If you provide a lot of items, say a couple dozen, most look and feels will use a JList instead of a JComboBox. I'll choose Barb, click OK, and it says name is Barb. That's our 3 methods: showMessageDialog, showConfirmDialog, showInputDialog. Something I should mention is that for all 3 methods, this parent component argument is allowed to be null. I strongly recommend that if you have any components displayed on the screen, that you actually provide a reference to one as the parent component. That will prevent dialogues from popping up on the wrong monitor for users that have multiple monitors. But if you don't have anything displaying and you want to show a dialog box anyway, you can pass a null and it'll work fine. Usually it will be centered in the main screen. JOptionPane has one more show method called showOptionDialog. And actually, all 3, showMessageDialog, showConfirmDialog, showInputDialog, eventually delegate to a call to showOptionDialog. But it's easiest to use one of those 3. JOption has many other methods, including constructors, that configure the contents of a dialog without actually popping it up. So you, the programmer, can get a reference to it, pop it up manually, and tweak it if you need to. But for most purposes, showMessageDialog, showConfirmationDialog, showInputDialog can handle anything you need them to. That's our lesson on JOptionPane. This lesson's on FileDialog and JFileChooser. We can use either of those classes, but FileDialog, which isn't technically a Swing component, usually looks better. JFileChooser, on the other hand, is more flexible, so I recommend that you use a FileDialog most of the time, unless you need some of the functionality that JFileChooser chooses and FileDialog lacks. I have a program here with a Save button and a Read button. Let's write listeners for these buttons. We'll start with the Save button. And since I recommend you use FileDialog, that's what we'll do. Add action listener. First thing we do is instantiate a FileDialog. I'll call it FD, new FileDialog. It takes 3 parameters. The first one is the parent, similar to the parent argument that we discussed in JOptionPane, but this has to be a frame or a dialog. The second argument is the title for the chooser dialog. And the third is the mode. It'll either be FileDialog.save or FileDialog.load. I need a reference to my frame, which I define down here. Now, it will work to pass null instead of an actual frame parent, but it's really a good idea, when possible, to pass in the true parent. So I'll just move the declaration up to the top so I can refer to it in my event handler. If I'd like, I can specify an initial directory for the file chooser. So I'm going to specify temp directory on my machine. Then to make the FileDialog appear, we call setVisibleTrue. Let's see how that works so far. So we started in the temp directory. The title of the dialog is please choose where to save. This button is called save. The key point is this is an actual native file chooser from my operating system, which happens to be macOS 10.10. If you run this on Windows, you'll get a real Windows file chooser. So I changed the pictures directory. And that's because I want to show you that on most operating systems, including Mac and Windows, if you don't set an initial directory, then it usually goes to where you last were automatically without having to write that in any code. Let me change this to load temporarily so we can see what that looks like. So reading dialog instead of a writing dialog. And it remembered we were in the pictures directory. Now this button is called open. And I can do anything with this that you could do with any other native file dialog. So for instance, I can change the display mode. I can click on some items and see previews. I can right-click and go Quick Look. After setVisibleTrue returns, we'd like to know which file the user chose. File dialog has a method called getFile that does that. So we can say if getFile is equal to null, this is a flag that the user canceled. Otherwise, getFile will return the file name, but not the entire file path. So to get the entire file path, you need to call both fd.getFile and fd.getDirectory. If you pass those two values to the file constructor, that gives you a reference to the file that was chosen. So if the user clicks the Save button, it says user chose private temp youradd.txt. But if the user cancels, even after typing something in here, it says user canceled. There's actually another way, in addition to getFile, to determine which file the user chose. And that's to call a method called getFiles, which returns an array of files. If the user cancels, this array will be 0 in length. This getFiles method wasn't included in the file dialog class until Java 7, released in mid-2011. So before then, getFile was the only way to tell. But the reason they added this getFiles method is because they also added a method called setMultipleMode. If you set this to true, the user can choose multiple files, not just a single file. At least they can for load file dialogs. Let me change it back to load. Whether save file dialogs support this depends on the operating system. So if I choose this file and this file, it lists both of the files here in this list. And the getFile method returns one of the two. But even if setMultipleMode is not set, you're free to use this method as long as you're sure you have Java 7 or newer. That's what you need to know about file dialog, but I might as well complete this method and actually write the file. And of course here, we'll pass in this file object, because that's the file we want to read. Pass it to the write method of our text area. Okay, let's add a listener for the read button. We'll use JFileChooser. I recommend that you use file dialog. An action listener. So the first thing we'll do is instantiate a JFileChooser. I'll call it FC. And I can call the noArgument constructor, but for JFileChooser, it's usually best to specify an initial directory by passing in a file object. File dialog used to call to setVisibleTrue to make the dialog actually appear. But JFileChooser has a different method for that. There are actually several methods. There's one called showOpenDialog, and there's also one called showSaveDialog. So where file dialog had you specify the mode in the constructor, JFileChooser doesn't care until you actually call one of these methods, either showOpenDialog or showSaveDialog. The argument to showSaveDialog or showOpenDialog is the parent, but this is more friendly than with file dialog, and it can be any component. So for instance, we can just pass in our text area. And another difference from file dialog is that this method returns a result, an integer code. So let's try this. There's the JFileChooser. It's definitely not the native file choosing component, but it works. With JFileChooser, the way we determine whether the user canceled or not is to check this result code. So if it's not equal to approve option, then probably the user canceled. The three possible values for results are approve option, cancel option, or error option. But usually you want to do the same thing whether it's canceled or errored, and so it doesn't matter. We can obtain the actual file by calling jfileChooser.getSelectedFile. And it says user chose temp/scratch2.txt. If you want the user to be able to select multiple files, you can enable that. Set multi-selection enabled, pass in true. And then to get all the files, we would call fc.getSelectedFiles. So it's similar to file dialog, but there's one important difference, which is if I do not set multi-selection enabled, then this will return an empty array, where with file dialog, even if multi-selection wasn't turned on, the getFiles method would return the single file chosen. That's not the case here. There's no point in calling getSelectedFiles without setting multi-selection enabled to true. Let me write the code that actually reads the file. I'll copy it from the other method and then change it. If you remember, the second argument to pass to a JTextComponent's read method is a description, and the file path serves as a pretty good description. Now let me discuss three things that JFileChooser can do that FileDialog can't. The first one is customizing the text on the button. I mentioned that we can call showOpenDialog or showSaveDialog, but we can also call this plain showDialog and pass in two arguments. The first one, as before, is a parent component. The second one is the text on the button in the FileChooser. Notice this button now reads Insert instead of Open. The second thing that JFileChooser can do is customize the appearance of these items. So you'll notice these icons that appear to the left, folder icons, document icons, or even the text of the files themselves. Presumably, content.java is the actual name of the file. But if for some reason you wanted the text to appear differently in this file dialog, you could do that. The way you customize these things is to call fc.setFileView. The FileView object you pass in has 5 methods to implement. But if you only want to change one of them, you can return null for all the others, and null means to default to the standard behavior. So I'm not going to actually do that. But if you're interested in changing some of those things, this is how you do it. Let me change this back to the showOpenDialog. The last thing I'd like to show you is the JFileChooser setAccessory method. This allows you to pass in any component, and it will appear to the right of the files listed. So for instance, I could create an accessory panel with border layout, and I could add some stuff to this panel. So we'll add the slider to the accessory panel. And let's add a checkbox. And maybe put a border on this panel. And again, we'll pass the whole thing to the setAccessory method. And you'll see it appears here. Now I'm not sure why you'd need a slider in your open file dialog, but the point is you can just pass any components in you want. Perhaps the most typical use of this is to specify a JLabel with an image icon on it, and whenever a user clicks on a file, to set that image to be a preview of the file. Or you can put a JTextArea in there, and whenever a user clicks on a file, put the first few lines in the JTextArea as a preview. For both of these examples, you need to know when the user clicked on a file. And if you need to do that, you can call fc.addPropertyChangeListener. And if you do that, you'll be notified whenever any property changes, and you can look for the ones that indicate the user clicking on a new file or the user changing to a different directory. That's our lesson on FileDialog and JFileChooser. We've reached the end of the course, so let's wrap it up. What have we learned? We've learned about frames, panes, and how to lay them out. We've learned about labels, images, and button components such as JButton, JCheckBox, and JRadioButton. We've learned about menus, menu items, menu bars, and pop-up menus. We've learned about sliders, spinners, the JList component, and combo boxes. We've learned about single-line and multi-line text components, including JTextField, JTextArea, and JTextPane. We've learned about tables, custom cell renderers, and custom cell editors. And finally, we've learned about JOptionPane dialogues and FileChooser dialogues. If you're curious, I recommend you take a look at the Java documentation for a swing component and take a look at all the methods it provides. But before I go, let me show you one more thing. I've taken a copy of our Hello World program and I've renamed it Hello World HTML. If you remember, this is what it does. Let me get rid of these set font and set foreground calls, and let's do something similar in a different way. If I start this string with the 6 characters, open angle bracket, HTML, close angle bracket, then JLabel will try to interpret the string as HTML. So for instance, I can put in a line break tag here, and my label will appear on 2 lines. Usually when I create a BR tag, I like to put a slash here in the XHTML style. This works fine with modern versions of Java, but it does confuse some older ones. So for greatest compatibility, I just leave it off. we can use this HTML feature to support multiple text styles in a single JLabel. Let me say span style equals, we'll specify some CSS style information, and say blue color, font size 18, font style italic, big, blue, and close the span element. And as you can see, it renders big and blue in italic, in a larger font size, and in the color blue. It's not just JLabel that supports this. Just about any Swing component that can handle strings can handle some HTML. If you're going to try anything even slightly complicated with your HTML, I recommend you do extensive testing to make sure there are no rendering or component sizing issues. Let me create a JButton with HTML. New JButton. The first 6 characters of the string are going to be open angle bracket, HTML, close angle bracket. And now let me create some center-aligned text. Paragraph, style equals, text align, colon, center. I'll say thanks, line break. Let's change the color of the second line. Color, colon, red. For, line break, watching, end paragraph. We'll add this to the Frames content pane. Here's a button with 3 lines of center-line text, the middle one red. Sometimes using this HTML feature in Swing can save you a lot of time.